Hey everyone, welcome to HashiTalks India 2024. It is my great privilege to welcome each one of you who joined us today to the biggest HashiCorp community virtual event in happening now. It's HashiTalks 2024. This is Saravanan. I am a HashiCorp ambassador since 2023. I am from the city of Chennai. I am the founder of a technology startup called Cloud Engine Labs. We are a DevOps and cloud solutions providing consulting firm, and we are planning to step into product development sooner. I always like to share my knowledge, and I always like to building in public. So that's who I am. So let's jump onto the session. So basically, like HashiTalks India is a virtual community conference focused on all things on HashiCorp technologies, where we have multiple great contents lined up for you to consume today. If you have questions or comments, we would love for you to interact with us in the chat. As you do, please keep in mind our code of conduct in virtual space. In general, be welcoming, inclusive, friendly, and patient. Be considerate, and most importantly, be respectful to others. You can review our code of conduct at hashicorp.com/community guidelines. With that, let's get started. We have awesome speakers lined up for you from all over the India, and they are going to talk about talk about the HashiCorp technologies and the HashiCorp suite of tools that may be focusing on infrastructure lifecycle management as well as security lifecycle management topics as well. Now, I'm going to introduce our first speaker for the day, Amit Kumar Jha. Amit is our opening speaker for HashiTalks India 2024. He's a solution architect working in HashiCorp. He has over 19 years of experience in cloud and infrastructure services design and delivery space. In this session, Amit is going to talk about how HashiCorp's ILM, infrastructure lifecycle management and security lifecycle management solutions help us to the journey of DPDP compliance in India that got recently introduced. Over to Amit for a great talk.
Hey guys, welcome and thanks for joining in. I really appreciate you finding out time for us. I'm gonna talk today about HashiCorp solutions that can help you with the DPDP, or to call it Digital Personal Data Protection Act, which was enacted by Government of India in the last August. And this is one of the key considerations for a lot of business. But before I get into all those things, let me just tell you a little about myself. Thanks, Savanan, for introducing me to the team, to the people. My name is Amit. I am a senior solutions engineer based out of Bangalore for HashiCorp. I look after Pan India, the whole of India. I work with a lot of clients and the customers and the vendors and the partners and everybody. So any challenges, anything for technical things, you can always reach out to me. With that, let's look at the brief agenda that I prepared for you. I wanted to talk about a little about what is DPDP, what are the key requirements. Once we look at the requirements, what is DPDP and what are the requirements, and then we can probably get into what is the solutions or what are the solutions from HashiCorp that can help you mitigate the risk that you have with DPDP that is coming in. And post that, once we look at the solutions, maybe I'll help you with what is the next thing that you can do to get started. With that, let's get started. Okay, so what is DPDP in all, right? DPDP, or the Digital Personal Data Protection Act of 2023, is India's first privacy law that regulates the processing of the digital personal data of each and every individual. Even if the data is collected and digitized later, maybe your data is collected somewhere sometime early, but it was digitized later. Even if the data was collected outside of India, but it's used to provide goods and services in India, then it is covered under the DPDP. So that is something that needs to be taken care of. It is a comprehensive multi-page documentation. You can see the first page on your screen right now. You can always scan the QR code that's there. It will take you to that page. So yeah, but please go ahead and scan that out later. It's a comprehensive multi-page documentation which goes into much details about who are the stakeholders. If you are a data principal, or you are a data fiduciary, or you are just a data processor, maybe your data is collected by someone else and you are just using that data or processing that data to take meaningful result out of it. If you are an appellate tribunal who's doing that, it defines the rights, responsibilities, and obligations that each and every party has, how to collect the data, how the processing of the data needs to happen, how the storage needs to happen, and everything. It gets into specific details about in context of data privacy and data security. That the act also has the provisions of penalty in both in terms of the data principal, which is probably you, or the data fiduciary who's collecting the data, or who the data processor. So it has clauses for penalty and as well. As I said, businesses now need to take care of how they collect the data, how they handle the data, how they manage the data, how they transfer the data, if they at all they are transferring the data to some other fiduciary or some other person to go ahead and probably work on the data, process the data, or maybe to a different geographical locations. So that is there. Let's double click on what are some of the key requirements for data for DPDP. Okay. So some of the key requirements that are dotted there on your screen is like data security and confidentiality, right? Organizations are bound to or mandated to implement robust security measures to protect the personal data from breaches and any unauthorized access by any other entity. So we can safely say that data should be encrypted, okay, and should be accessible to the right users only. The authorization and authentication becomes becomes a key to this data which is stored. It goes ahead to consent management, which again is the data, whether the user has given the consent to have the data being used or not. That's important. Data minimization and purpose limitations. Once the data is used, there has to be some kind of a TTL that's going, and there has to be some kind of a policy that the data has to be does not have to be available after a certain period of time that it's used. Then there is access control and auditability. That's also a key requirement when it comes to the data, right? Who can access the data? That's very important. We have to make sure we regulate who can access the data. There has to be an authentication that needs to happen, and as I said, there has to be authorization on what data is available, what keys are available, how can the data be decrypted or encrypted, or where it is stored, and that is what becomes key. And once that data is accessed, DPDP also makes sure that it has a clause that all the access to the data is logged. That logging and reporting is a key aspect of this DPDP Act as well. Then there is data portability and interoperability. Individuals who have the right to port the data, allowing them to transfer the data from one service provider to another. The data transfers are also restricted based on countries. Okay, so by default, you can transfer the data to other countries or other geographical locations, but it's restricted to some of the countries. So again, the policy management for making sure the data is not transferred becomes key. Even if the data is leaked or uh, or somehow being accessed in some of the restricted geographical locations, we need to have a policy and a mechanism to enforce that the data is not readable and not shareable across different geographies. Now, I can think of multiple products which we have at HashiCorp that can be key in achieving some of these requirements, right? Like all these requirements that have been stated, that have been detailed in the DPDP Act. I can think of a lot of technologies. Vault becomes key here. Okay, Vault is primary to go ahead and secure the data. There are various encryption methods, and I'll talk a little more about them in the future slides. It becomes key to making sure the data is encrypted. Okay, it also is key to have that authentication and authorization in place when the data is accessed by multiple users, multiple uh, services, or multiple providers, and everything. So it becomes key. Then boundary is one of the key elements here. Boundary can help you with the access of the system and data. It can make sure that you can regulate what data or what systems can be accessed by whom. On top of that, boundary can also help you ensuring that the user who's accessing the data does not have the credentials or does not have the access beyond a certain point in time. So TTL becomes one of the key aspects of all the products that we have. All the products, they enforce TTL. The services which are available or the credentials which are available live for a shorter period of time, and once the credentials are being used, these credentials are removed so the credentials cannot be exploited. So that is something that comes into picture. I was talking a lot about policies, right? So you can write policies in something called Sentinel, which becomes key again. So Sentinel is a policy engine that can run. It works both with Vault and other products. It becomes a key to enforce these policies as well. All these, when all these things are done, everything is being logged, and the logs are detailed, which can be used for creating the reports or dashboards or anything that is required by the law or the regulation to make sure that that is available to the right authorities. So having said all that things, let's look at some of the HashiCorp solutions that can help you with all these things. And I'll probably not discuss all of them. I'll just discuss one or two of them. First one is encryption anywhere is something that is something that I'm very fond of. So Vault has various data protection capabilities. Okay, these data protection capabilities are designed to satisfy a full range of security and usability according to the user's need. Okay, it simplifies the protection of the data. It simplifies the protection of data in transit, in when the data is at rest, or it is at cloud or at data center. By providing the traditional data encryption, it can be your normal data encryption that needs to be done, or it can be the format preserving encryption, or maybe data masking. These things are mandated by a lot of regulatory authorities these days. So that is something that you can look at. There is another thing that comes with Vault is called data masking. You can mask the data as and when required. You can tokenize the data, which is again something which is coming up a lot in the regulations by a lot of regulatory authorities in India. You can have a central key management system, And that key management system can in turn go ahead and encrypt all the data that is there in different entities, maybe a database, maybe a data store somewhere, and you can go ahead and encrypt those data source data sets or the databases using these key managements or using these key. And this can be rotated. Their whole life cycle of these key will be maintained by Vault. You don't have to worry about a thing. Looking a little more right into Vault, Vault provides encryption as a service with a centralized key management I was talking about, right? So Vault in itself does not go ahead and store the data. It'll encrypt the data and it'll be available as we want to call it, like, or as we like to call it, encryption as a service, which simplifies the encrypting of data during transit or maybe at rest or wherever the data is stored. All actions that are there involved can be performed using multiple ways. It can be API driven or API driven encryption. You can encrypt and decrypt the application data with an HTTP API call. Okay, the key management, the encryption algorithm, or any other action that you want to offload or that you want to perform. All those things can be done using API. Apart from API, there is a UI which is available. There is a CLI method that can be used by users to go ahead and use Vault. Encryption key rolling, as I said, you don't have to worry about the life cycle management of the keys that are being generated. New keys will be rolled out and the infrastructure, and you don't have to do it manually. Vault also provides the protection with FIPS 140-2 and the cryptographic compliance, right? It integrates with FIPS 140-2 certified HSM boxes to ensure that the critical security parameters are protected and are compliant as per the regulatory needs of the data. Replication filters, you can have data set up in one vault and can replicate it to a different location and region. As I was talking about the geographic regions where the data should not be available or should not be accessible, right? You can restrict or you can filter what kind of a data keys or what kind of a data within vault can be replicated from one vault to another. That is something which is again important when it comes to vault. If I talk about console, which is another tool which integrates very well with Vault, right? You can create a very secure, trusted connection kind of a setup for your applications, right? And all the services. Nowadays, we see that the applications are broken down into large number of services, right? All these services need to connect to each other. So console gives you a kind of service registry help which will help you let the services access another service based on the policies that you create. So only the services that are required to connect with other services within the application, it will create a mess. Again, all the communication with the services externally and everything will be can be encrypted using a TLS or MTLS. MTLS requires the service to manually authenticate the connection, mutually authenticate the connection based on the trusted authority, right? Both these services has to mutually authenticate before they can make this connection. These certificates that are required for these TLS and the secured connections, right? They are generated and rolled or rotated by intermediate CA server, which Vault can also act as an intermediate CA server. And this can be done in an automated fashion or with minimal intervention. That is something which is key. Another solution that I can think of is your zero trust security, right? Here is your application and users, which is spread over a network. With zero trust, I would say that we recommend trust nothing and authenticate everything, be it a human user, be it a machine, be it any other kind of entity who's accessing the data, right? Or accessing the application has to be authenticated. So Vault enables the enterprise to centrally store and access, distribute any kind of secrets, any kind of tokens, passwords, certificates, or maybe encryption keys across any of the public cloud environment and or anything, right? Any kind of environment. Both the both the application and the user can kind of generate just-in-time credentials with Vault, right? They can create just-in-time credentials. Once the Vault is introduced, it can create just-in-time credentials for accessing the cloud or probably database. So hence, the credentials are now short-lived, and only the authorized user have the credentials for any particular given of a given point in time. This can be regulated using policy. It can be from seconds or minutes to hours or days. So that kind of a credential can be generated. Once these credentials are generated, you can use the credential, or the user can use the credentials. When the use is done, or the policy dictates the credentials to be scrapped, right? The credentials will be removed from existence. It will be scrapped, or it will be removed. It will be scrubbed, and the user no longer has the credentials or the access to the database. This helps secure the applications and the application data uh, with the while the credential is not available for the user. The challenge these days is that we have a lot of entities, we have a lot of clouds, we have a lot of environments, right? Today we have an on-prem environment. Tomorrow we might have something over AWS or a public cloud. Tomorrow, the day after tomorrow, maybe we have something over GCP or Azure, or maybe any of the cloud providers, right? And all these cloud providers, right, they will have their own kind of uh, authentication mechanism. So that becomes a bit of a challenge. So what Vault does is it acts as an identity broker. Okay, Vault can broker the identities of these users across multiple applications, multiple networks, or multiple such kind of entities. It can be cloud, it can be your network identities, it can be your application identity. All these things can be clubbed to make sure that we have a single entity which is available for Vault to authenticate and then provide the policy or enforce the policy that has been configured to ensure that the access which is approved or which is regulated as per the policy is provided to the user, and hence the data is secured. Hence, you are compliant with all these regulatory acts. That is something that is important to understand. Moving ahead with network and identity. Okay, so console enables the machine-to-machine access, enforcing the authentication between these services. I was talking about like multiple applications or multiple services which are interdependent or which need to communicate to each other, right? All those machine-to-machine communication, right? If you want to enforce authentication, that the connections between those applications, those services, those machines needs to be authenticated before they are approved or before the user can go ahead and use them. That can be done using console. Console codifies the authorization and the traffic rules, right? You can codify what services can go ahead and access which all services, what and ensure that the traffic is encrypted. You can automate the identity based access to these services. The console also actually lets you go ahead and discover the services which are deployed. Like, let's say if you have some kind of a cloud service which is dynamic in nature, many times the entity within the services come up and go down. Maybe a web server which is stateless, and many times based on the needs or based on the requirement, the services are expanded. Multiple servers are brought up, and they wind up was the the request subsides, right? So we can automate these service discovery, we can automate these network configurations, we can automate that whenever the service comes up, it is still making sure that those are secured, the connectivity is secured, there is no breach in that kind of connection. So that is something that is available. All these things, user gets or machine gets authenticated using Vault, the services are, or machines are getting authenticated and connecting. What is lacking is the human aspect of it, right? The administrators will still have the credentials, will still be required to access the servers. You can introduce boundary into the mix. Now boundary is a PAM solution which is available for you to control how user to machine communication or user to human to machine access is provided. Traditionally, what we used to do is we used to have VPNs, we used to have Bastion host or jump servers configured in all entities or all infrastructure that we have. We used to configure VPNs from one infrastructure to another. One that always was creating a challenge of latency, of the speed. Then there was a challenge of credential sprawl, right? Credentials used to be shared across the network, across different VPN connections, and that was always the challenge, right? So with Boundary introduced, right? Boundary can integrate with Vault and use that just-in-time credentials that I was talking about, so that the access provided to a particular database, to a particular portal or particular server, right, particular service, gets regulated. Now the users are making, you can make sure that the users don't have any long-term living credentials, or even they don't even know about the credentials at all. They can go ahead and use that transparently. They can just go ahead, there is a host, they can just go ahead and click on connect, and the user gets connected. They don't have to go ahead and put in or key in any kind of credential. And hence we can minimize the exposure that we have using credentials or using long-lived credentials, and those things can be minimized within the network. It can be set up across different clouds, so that centrally a user can go ahead and connect to multiple clouds, and they don't have to connect to those clouds or those bastion hosts to access those services. So that is what this zero trust security brings onto the table. Moving ahead, auditing and compliance. We can introduce Terraform. Terraform is infrastructure as a code solution, and everybody who knows HashiCorp or even has worked sometime in IT industry should be aware of Terraform, I guess. That provides a consistent solution for you to be able to deploy hundreds and hundreds of workloads across clouds, across different infrastructures, across the organizations and everything. It's up to you how you want to use it. So while we are doing that that infrastructure as a code, right? And I was talking about Sentinel and all those things. So there are policies that can be implemented that this connectivity or this infrastructure can only talk to this infrastructure. Those will again secure the data that's stored in the infrastructure that you're creating. One. The second thing is that you can also make sure that those policies enforce who can access that data. So all these Terraform, Vault, and Boundary, they come together and provide you a secure solution to ensure that your data is secured at all point in time, you're compliant, and you're not moving overboard, or you're not against the compliance like DPDP or any other regulatory compliance. So what's next? If I talk about next, I can certainly go ahead, or we can certainly go ahead and have a technical follow-up. We can have a strategy where we can help you understand the business value that the whole solution brings out to the table. We can have technical workshops. Please reach out to us. Please reach out to HashiCorp personnel, the community, the user group, and they will be able to help you understand how we can proceed with this. If you want to read a little more about the source of my data or the source of the solutions that I was talking about, here are the QR codes that you can scan and go ahead and read a little more about it. I'm happy to go ahead and interact with you and explain this in a little more detail and how exactly these work. Maybe you want to read about the data Personal Data Protection Act. That's the link where you can go ahead and use that. So with that said, I think so I'll conclude the session. And yeah, Seven, you're still around?
Wow, what a way to start the HashiTalks India 2024. Thank you, Amit, for providing solution insights on implementing DPDP compliance using HashiCorp suite of tools. And join a HashiCorp. There is a community groups all around the world running. It's called the HashiCorp user group. So you can join a HashiCorp user group. The HUG program spans the world in 63 countries with over 50,000 HashiCorp users across 180 chapters. There are 19 HUG chapters in India, and we want you to join. We should visit hashi.co/hugs to find a chapter near you, or to learn how to start your own on your own. You can reach out to community people. So it's time to introduce our next speaker, Nikita Maurya. Nikita is a staff cloud platform engineer in AppDirect. Nikita has played a pivotal role in architecting and optimizing solutions that drive digital transformation to new heights. In this session, Nikita will discuss Terraform standardization, refactoring, and the integration of manually and IAC provisioned resources into the Terraform state. Also, the migration journey from Terraform open source to Terraform Cloud. So the floor is all yours, Nikita. All the best.
Good morning, everyone. I'm so excited to be here with all of you at HashiTalk India. Whether you are tuning in from your home, office, or anywhere else, thank you for joining me today. I am Nikita Maurya, a staff cloud platform engineer at AppDirect. I have been working in a world of cloud technology, automation, and DevOps for over 7 years. I'm passionate about using Terraform and infrastructure as code to create a scalable, efficient, and cloud infrastructure. Along the way, I have earned certification like AWS Certified Solution Architect Professional, AWS Developer Associate, and Terraform Associate, which have enabled me to master cloud infrastructure and automation best practices. Today, I'm thrilled to share with you Terraform Everywhere, standardization best practices, and cloud integration. Feel free to drop any question in the live chat and I'll sure to address them at the end of the session. Let's dive in. Here, what we are covering today. We'll start with an introduction to Terraform and why it is the foundation of our infrastructure. Next, we will talk about the importance of standardization and refactoring, tuning Terraform into robust and scalable tool for teams. After that, I'll share the 6 best practices we follow at AppDirect based on the real world challenges and lessons. Then, the fun part, our migration journey from Terraform open source to Terraform cloud. We'll wrap up with the benefits we have seen and of course Q&A for your burning question. So, what is Terraform? So, Terraform by HashiCorp is an open source infrastructure as code tool. It lets you define your cloud infrastructure in a declarative configuration language called SCL. Here, the power of Terraform. You can define infrastructure once and use it across multiple providers like AWS, Azure, or GCP. This is not only reduce manual work but necessary ensure consistency and version control for your infrastructure. Imagine this. You are not clicking buttons in a cloud console or running ad hoc script. You are managing your infrastructure like the manage your code like Git and workflow and automation. So let's talk about why standardization and refactoring are crucial. Without these practices, you end up with inconsistent code. Resource names don't follow pattern, modules are reused poorly, and teams struggle to collaborate. Standardization brings clarity, clear naming convention, and consistent structure. On the other hand, refactoring. Refactoring, that's where you take an existing code base and make it better, simpler, scalable, and easier to maintain. For example, modularizing commonly used infrastructure patterns like VPC, IAM roles, or security group. Think of this way. Standardization sets the rule of the game and refactoring ensures the game is played efficiently. Now, let's dive into 6 best practices we follow at AppDirect. Let's talk about modular code in a Terraform. Imagine you are building a huge structure and instead of recreating the same part over and over, you create reusable building block. This is exactly what we do with infrastructure in Terraform. By structuring infrastructure into modules like networking, security, and compute, we make our code scalable and maintainable. You can easily reuse the same modules for a different project without reinventing the wheel. That benefits it reduces redundancy, making it easier to manage and ensure your resources are always consistent. This is also simplifies update and changes because you can modify a module one place and the update automatically propagates across all instances. In short, it's about working smarter, not harder. Now, moving on the naming convention. Consistent naming isn't just about aesthetic, it's practical approach that makes your infrastructure easier to manage and troubleshoot. Think about how quickly things can get messy if names are inconsistent. Debugging issue, conducting audits, or collaborating with teammates become a challenge. For instance, we follow clear, predictable naming patterns using prefix like AWS instance for EC2 instance, Azure Network for networking resources, or Prod VPC for production VPC. This make it immediately clear with what each resource is, where it belongs, and which environment it is in. So, when you look at a resource name like AWS instance dot web server, you instantly know it's an AWS EC2 instance running the web server rule. This level clarity cuts down on the time spent figuring out what's what and improve efficiently across the board. The third best practices which we follow Terraform state file, okay, and the state management. So Terraform state file is its brain. It know what deployed. We use Terraform Cloud as a remote backend to store this state. This enable locking, ensuring no two developers can accidentally modify the same resource at once. After that, the fourth point is environment isolation. So we isolate environment, dev, staging, and prod using Terraform Workspace or separate state file. Terraform Workspace will work in a smaller configuration or a smaller environment. But if you have a Terraform multiple projects and multiple environments such as dev, staging, and prod, so you have to think about separate state files. This prevents conflict like accidental update to production when testing a new feature. Now, the fifth point is version pinging. So, when we talk about best practices, version pinging is also a most important point. So, provider and module version are pinned in our configuration to prevent breaking changes during upgrades. For instance, log a specific version for an AWS provider ensures predictable behavior across deployment. The last point, and very important, documentation and comments. Clear comments make Terraform configuration easier to understand and maintain. Whether you are onboarding a new teammate or revisiting your code after a month, good documentation saves times and confusion. Now, after discussing the best practices, let's understand what is Terraform Cloud. So, a managed service for running Terraform with enhanced collaboration, security, automation features. So, that is Terraform Cloud. So, why to migrate Terraform Cloud? Okay, Terraform Cloud provides a more robust environment for collaboration and scalability compared to using open source Terraform with local state files or S3 backend. With Terraform Cloud, you get team based workflow, secure remote state storage, policy enforcement, and integration with version control platform. It also simplifies access control and make it easier to scale infrastructure as team grows. Now, we will discuss more about the migration process and the Terraform open source to Terraform Cloud journey. So the migration process begins with assessing your existing Terraform setup. You need to set up a Terraform Cloud account and create an organization. Migrate your state file to Terraform Cloud remote backend. And then third step is set up your version control system like GitLab, Bitbucket or GitHub. It is important to test a new setup in a staging environment before fully transitioning to ensure minimal disruption. So this point we have to take care of and point to note when we are doing the migration from Terraform open source to Terraform Cloud. So let's discuss about when we talk about Terraform open source. So when you talk about Terraform open source, which means when you store your Terraform state file locally or a backend like S3 bucket. Here's a code snippet we have used for backend S3, where you can see the bucket where we can store the state file and the region and the DynamoDB to log the state file. So when we do the Terraform init, Terraform init initialize your Terraform configuration, download provider plugin, and set up the backend. When using S3 backend, Terraform stores the state file remotely is an S3 backend, ensuring team collaborate and state consistency. DynamoDB is used to state locking, preventing concurrent changes to the state file. This setup ensures secure remote state management with versioning and locking, especially used in Teams environment. So I have used this Terraform init, plan and apply to understand and give you the details about when we are doing the Terraform open source. These are the things and these are the apply commands and we have to apply from our local. So Terraform plan. The Terraform plan command generates an execution plan. It shows you that what Terraform will do when you run apply without actually making changes. It compares the current state from the state file with the desired configuration and provides a list of action, add, change and destroy resources. This is safety check. You get a preview of what Terraform intend to do, so you can review and confirm everything is correct before making changes to your infrastructure. Now, the final step is Terraform apply. So after reviewing the plan, you use Terraform apply to apply the changes. This command actually makes changes to your infrastructure, creating, updating or destroying resources. Before executing Terraform, will ask for confirmation unless you use autoapprove to skip the step. After applying, Terraform will update the state file to reflect the changes that have been made. So these are all steps that we have showed you recently. So Terraform init, Terraform plan or Terraform apply. These are we are doing when we are configuring Terraform open source and we are applying those changes from our CLI. So with AWS S3 dashboard, select the S3 bucket containing your remote state file. So you will find Terraform state file in the bucket. Now, to migrate to Terraform Cloud, first you need to create an HCP account and create organization. Terraform Cloud Organization is a container managing team, workspace, and access control. Think of the organization as the umbrella that holds everything together. It's where you manage teams like DevOps and infrastructure, workspace, and permission. It's also where you link your version control repository, GitHub, and GitLab and set policies using Sentinel. So Terraform Cloud Workspace is a unit within an organization for managing infrastructure. Workspace are where actual infrastructures are live. They represent a specific environment, example dev, staging, prod, and each has its own state file. This isolation of state means that change in one workplace won't affect other. So in order to migrate your Terraform open source to Terraform Cloud, you have to set up your organization and workspace. After that, you have to integrate your GitHub account and other variable to configure in such a way that we can start the migration process. So to migrate your state from S3 to HCP Terraform, you need to replace the backend configuration. Here you have to update the backend to Terraform Cloud and the host name will be Terraform Cloud URL. Organization, the organization you created in the Terraform Cloud and the workspace. So you have to update all these three and make sure that you comment the or remove the Terraform backend of S3 or your local one. So after doing the Terraform backend configuration, you can do the Terraform login. So Terraform login is basically you have to log into Terraform, which pop up the notification to create an API token, which does the job for your user authentication. Once that is done, you can do the migration plan or you can initiate the migration plan from S3 backend to Terraform Cloud. So when you do after login, you can do the Terraform init where you can see migrating from backend S3 to HCP Terraform. Once you migrate your Terraform state file, you can go to your workspace and select the state, and then you can see the new state is been pushed. So when you're migrating from an existing environment or existing Terraform open source resources to Terraform Cloud, you won't see any further changes because you have did the brainstorming and understanding the things that you will migrate, and no infrastructure changes apart from like outside of Terraform will occur. So that's the best practices that you can follow migrating from Terraform open source to Terraform Cloud. Now, our migration to Terraform Cloud brought several benefits. Let's understand key benefits and lesson learned. So the benefits are improved collaboration with shared workspace and centralized state, streamed provisioning via automated workflow, enhanced governance with policy as code. However, we learned that proper planning and training are vital for a smooth transition, as team adoption and adjustment to cloud-based workflow takes time. So, thank you all for your time and attention today. If you have any question or need further clarification on Terraform concept, feel free to ask now and reach out to me later. I hope this session helped you better understand how Terraform works and how you can leverage it for your infrastructure automation.
Yeah, it was an awesome talk, Nikita. Thank you. Thank you for deep diving into Terraform best practices, refactoring techniques, and migrating from Terraform open source to HashiCorp Cloud Terraform. Information shared by Nikita could be helpful for anyone starting the Terraform learning journey because she covered all the basics of best practices and refactoring everything, right? So, yeah. So before moving on to next speaker, there is an announcement from HashiCorp. HashiCorp is hiring in India. They are looking for senior SRE, senior front-end engineer, senior product manager, senior performance engineer, and many other positions. Visit hashi.co/hire.in. There is a website displayed in the screen. You can visit there and apply for the positions. So here comes the next speaker. So in case if you have missed attending HashiConf, we want to share an announcement that were made during HashiConf. As an ambassador, I got a chance to be part of HashiConf 2024. It was great to be there and meeting all the folks from HashiConf and watching the keynote from Armon live. So there are a whole lot of announcement made with respect to infrastructure lifecycle management as well as security lifecycle management uh, from the HashiCorp suite of tools. So please welcome Jack Ludberg, who will share a recap of announcements given at HashiConf 2024.
I'm Jake Lundberg. I'm a field CTO here at HashiCorp. I've got a link to my LinkedIn here, or QR code for my LinkedIn if you want to follow this conversation out of band, or you can reach me at aquaman@hashicorp.com. I guess you can put that inside of there. But we're here to cover the HashiConf 2024 recap. In case you missed the conference or slept through the keynotes or had a meeting or something along those lines. One thing I like to do just for the participants inside of here, just kind of do a introduction of yourself. I am, again, Jake Lundberg. I'm in Edmond, Oklahoma, and my favorite HashiCorp product is Nomad, which I think is the unsung hero of the application sort of scheduling environment. Like I said, feel free to pop any questions in the chat. I'll either answer those in line or follow up at the end of the session. So, oops, well, that's not moving forward. Okay, so before we dive into the updates, I think it's really helpful to understand the overall strategy for HashiCorp and why we're developing the features and capabilities that I'll be talking about. So if we look at the application delivery process, it's typically broken up into four main categories: the application development lifecycle with tools like your VCS systems, GitHub, GitLab, and the likes, things like Artifactory to store those artifacts once the code has been done, and then scanning tools, both sort of pre and post processing for the code functions that are in there. And we pass that off into the actual infrastructure that helps to define and manage the resources that those applications live on. And then following up after that is the security lifecycle management to securely connect all of our applications and users to any of our necessary endpoints. And then lastly, all the observability tooling to help us really understand the core metrics around availability and performance of those applications and the infrastructure. And where HashiCorp fits in is that we're a leader in the infrastructure and security lifecycle management space. And as application delivery architecture has become much more complex, our customers have tasked us with helping to reduce some of that operational burden and complexity. And that's where HashiCorp created the infrastructure cloud, is really to help those companies deliver infrastructure and security lifecycle management. And we do this all in a unified system that we call the HashiCorp Cloud Platform. And through the years of being a critical technology partner for some of the most respected companies and brands in the world, we've heard a lot of common requests. And so there are items like streamline the onboarding and management of our infrastructure. So how do we get started in a very fast time to avoid any of your lengthy provisioning and configuration workflows? And how do you kind of eliminate the cost and overhead of actively managing that underlying infrastructure? We want to be well integrated with lots of different products. So beginning with like simple use cases of infrastructure provisioning or secrets management, and then extending that into more complex use cases like including image lifecycle management with the infrastructure and integrating more privileged access management workflows into those environments as well. How do we lower the infrastructure operational cost for infrastructure and securities cycle solutions? And the way that we do this is let HashiCorp actually run some of those solutions for you, again, in the HashiCorp Cloud Platform, so that we can abstract away some of the difficulties of managing. We realize that customers have a wide variety of tooling, and it's increasingly becoming more complex as we add in things like AI workloads and more automated SaaS-based products. How do we make sure that all of our products are upgraded automatically? There's a lot of folks who are attacking our systems, and one of the core fundamentals of software processes is how do we update that software to release some of those vulnerabilities that we have. HCP Cloud Platform or the HashiCorp Cloud Platform allows folks to do automated system upgrades, so you don't have to manage those on your own. And then how do we address some of the scalability concerns as our clients have infrastructures that are worldwide with high uptime requirements and high levels of resiliency? How do we scale those operations out across there, and then allow for better availability and disaster recovery across all of the regions in which our customers live? Currently, HCP is located in North America and Europe, with plans to extend into Asia Pacific in the future. And then how do we create a common level of services between all these products that folks are using, including like Terraform, Vault, Nomad, and so forth, to allow you to have a seamless integration with any of your SaaS-based solutions? Over the last decade and thousands of customers, we've come to see a very standard set of phases in cloud adoption. So stage one is kind of like the experimental phase. You kind of think of these as like crawl, walk, run. So at the stage, typically, developers and operators are just kind of kicking the tires on some of these new technologies and providing some of these more tactical solutions. HashiCorp solutions, often used within that infrastructure and security space. But as folks start to move into stage two, and especially with highly regulated companies or folks that have sort of a large amount of employees inside of them, they have to take a slightly different kind of approach, because all these ad hoc levels of technologies really increase the level of variance within those environments. And so we see firms start to really standardize their processes of automation and work towards tool reduction, so that they can simplify the buying process, as well as the way that we share all of our capabilities across a wide variety of different business units. And then as we get from centralization and collaboration, how do we work towards more self-service operations in the long run and adopt this across a wide variety of business units and a wide variety of capabilities within these various companies? And we realize that organizational complexity can be a big sticking point for folks. So how do we create this standardized automation that allow folks to more rapidly adopt some of these modern automation techniques, but be able to spread it across more complex organizational environments? So if we kind of like dig into the adoption journey of like where most of our customers go from, it's it is that kind of ease of use, that crawl, walk, run. How do we experiment with the sort of core assets, and then how do we kind of migrate these things into a more collaborative space, both in the infrastructure and the security space. So allowing you to publish golden workflows with folks, applying things like policy or least privilege access across a global control plane. And then lastly, some more of the more advanced use cases around, no code provisioning or self-service type provisioning, the ability to do long-term lifecycle management of your images and assets that are inside the cloud. Remediating any kind of issues that you might have with any of those things, and then bubbling up all this information to your operations and security teams, so they have an understanding of where the risk in your environments are at over time. And so, again, just kind of core fundamentals of how we see people that adopt our software over time. The vast majority of where we kind of focus our energies are really around how do we help you reduce cost within your environments. Cloud environments can be extremely costly when not managed properly. How do we reduce the risk of like breaches, or helping you pass through some of those compliance gates a little bit faster? And then sort of lastly, how do we speed up your operations, allowing your developers to have greater senses of efficiencies as well as economies of scale as they begin to adopt these automation primitives as well. But if we look at some of the quantification of some of these risks in these various categories, 94% of organizations that were surveyed have some kind of amount of cloud waste inside their environment. I feel like it's even low. I want to talk to the 6% of the firms that have zero cloud waste, and about on average, about 35% of the average spend inside the cloud. And I've seen some extreme cases, even at my last job for a little while before we got our cost management under wraps. We were at 500% overages inside of those. As people get more disciplined in the cloud, we can reduce those costs. But how can you get those even further and really focus on increasing those margins? If you see that large number inside of there, your margins are probably nowhere near as high as what it is that you have inside your cloud base. So in about 27% of firms have had some kind of a breach in their public cloud infrastructure, again, increasing fines in the cost category, and decreasing some of the trust that you have from your consumers as well. And then about 65% of the security challenges that we see arise from misconfiguration. So how do we reduce some of that human variance inside of those environments and the configuration infrastructure by creating automation as a primitive that people can align behind? So I'm going to start now and just kind of go into some of the releases that we have in the infrastructure line. And I'm going to start off with just a quick summary. So some of the major things that were done is HTTP Packer CI/CD pipelines. We've got Terraform stacks. I'm going to spend a little bit of time inside of there. The HTTP Terraform module lifecycle management and ephemeral workspaces. The ability for you to do automatic migrations with Terraform. My favorite product, again, is Nomad. So talk about some of the GPU enhancements that we have there. And lastly, a little bit deeper dive into our HCP Waypoint product, which is designed to be that internal developer platform for self-service operations of that infrastructure and application environments. Okay. Over time, we've noticed that some common patterns of how development and operation teams actually work together. And sometimes those, we're at odds with the goals of the developers to move as quickly as possible, while that operations team is really worried about creating best-in-class infrastructure to run those applications in the most secure and efficient way. Where HashiCorp has been very good at day zero and day one operations in the past, we're increasingly tasked with solving day two through end problems like automated patch releases, managing drift within our cloud environments, and then providing for better cost controls. And this is why we've shifted to holistically look at infrastructure lifecycle management. Our infrastructure lifecycle management portfolio, which consists of Terraform, Packer, Waypoint, and my favorite, Nomad, helps you put a system in place so that you can have a programmatic approach to build your infrastructure and all the related images, deploy all those necessary resources, and then, of course, manage the lifecycle of that infrastructure over time. we're very effective at providing that central control plane for all infrastructure because we integrate with a broad provider ecosystem. Today, Terraform has over 4,500 providers. Yesterday, I said 3,000, and one of my SEs corrected me, and I was like, wow, 4,500 different providers, and those are the technologies in which you integrate. Last year at this time, we're at 3,700. Even I was even low at that particular number. And providers, again, are the API interfaces into all those technologies. So think the cloud service providers. That's probably 6 providers because each of them has multiple versions of their APIs. That's 6 out of 4,500. So you can control everything from networking devices to IoT devices, and even weird stuff like ordering Domino's pizza through the Terraform provider. We have over 17,000 modules in our private or public module registry, and then you can leverage more than 25 different run task integrations with partners that cover things like security and code scanning, cost control, and regulatory compliance. So again, the ecosystem within our infrastructure lifecycle management is just absolutely massive. The first announcement I'm going to talk about is the HTTP Packer CI/CD metadata. So this helps you track all of your metadata in an artifact registry. This became generally available back in July. And really what this does is it solves for the need for tracking and visibility into information about the creation and configuration of your image builds. And so this can help verify legitimacy and compliance within your application delivery supply chains. HTTP Packer now provides that ability to track pipeline metadata in the artifact registry, including the CI/CD information, such as the pipeline ID and job names, details on the operating system, VCS commits, and so on and so forth. And so really allowing you with that extended visibility into what that application delivery chain looks like. And this enhancement grants HTTP Packer the level 1 SLSA compliance, or SLSA, that was defined by Google. As we move into like kind of the more deployment stage, one of our main announcements at last year's HashiConf is that we previewed Terraform Stacks, a new way to simplify infrastructure provisioning and management at scale. So this year at HashiConf, we brought Stacks, that are next generation of Terraform infrastructure as code, into public beta. Stacks aims to address some of the limitations of our workspace-only approach, which leaks some of the complexity, like our workspace settings and variable sets, and then the definition of the relationships between our more complex infrastructure architectures. With Stacks, we're reducing the complexity by defining all of these relationships in HCL code to allow for more rapid sharing and repeated use of more complex architectures with minimal friction. Terraform Stacks is a single point of planning and updating for all of your infrastructure and the inputs and dependencies. And just kind of think of it as like a little bit more, rich dependency management and workflows around managing things like development environments or multi-region capabilities. Right now, HTTP Terraform organizations will have access to the public beta for use on up to 500 resources. And I have to stress this again because I think there's a point of contention I've noticed with some customers I've talked to, is that the Stacks beta will only be available for HTTP Terraform users. If you're on Terraform Cloud, you can migrate into HTTP Terraform. If you're on Terraform Enterprise, also the same thing available. Moving into HTTP Terraform will allow you access to Stacks. Of course, as these things become GA, they may become more widely available across the other technologies that we have. As part of the Stacks and public beta, we have 2 new features solving for kind of a completely new use case. We have deferred changes, which allows Terraform to produce a partial plan when it encounters too many unknown values. I can't talk, without halting any of your operations. So this helps users work through some of these kind of edge casey situations a little bit more easily, accelerating your ability to use Terraform for Kubernetes-based workflows. We also have orchestration rules, which allows customers using HCL to automate repetitive actions like automatic approvals when certain criteria are met. So if you know for sure that you're going to approve something based off from some criteria inside of there, I'm just kind of simplifying the ability for doing auto applies without having to YOLO completely and auto apply in the back end. So giving you that flexibility of maybe a policy-based management or an automated policy-based management approvals. Stack streamlines the provisioning and management of Kubernetes workloads by allowing customers to deploy in one single configuration instead of having to manage, multiple independent Terraform configurations. So think like multiple workspaces that you have to kind of manually tie together. How do you create a consistent dashboard forever to be able to do this? Just increasing the time to market for using Terraform for doing more complex environmental deployments. Next, we'll talk about the HEP Terraform module lifecycle management that helps you improve communication for updates and especially for any of your modules. So modules are the basic unit for reuse within all of our organizations as they standardize on infrastructure code provisioning. And the module registry allows for that sharing of tested and validated modules to your end users. But over time, there's usually a need for folks to deprecate some of the older modules because you've probably got many different versions and enforce updating those versions over time. So maybe you don't have some of the limitations that you had in those previous versions, especially when you're thinking about security and compliance issues. So this requires some kind of a deprecation process. We've got to have visibility into where those modules are being used and a way to push notifications to the users so that they can then migrate those modules at some later time. And so again, the concept of like we've updated these things, we've let our users know they have to replace them. And we call this module lifecycle management. Currently, this is in our public beta. I'm not sure about you, but if you've ever had your management ask you to reduce cost, it is a daunting task. You've got all kinds of disciplines around things like reserved instances and being able to decorate your workload so you understand where your costs are at. As these self-service operations in the cloud become increasingly common, customers often see a proliferation of workspaces and environments that live a lot longer than necessary because they should be short-lived because they're for test or QA or something along those lines. Another thing is that we have projects that may no longer be operating in the cloud. So maybe an application lived for like a couple of years and has been updated or migrated, and so a good portion of cost overages are just simply due to people not turning off those resources or right-sizing those resources over time. We originally released ephemeral workspaces at the end of 2023. And what ephemeral workspaces do is they help you set a time limit on infrastructure by using some auto destroy settings. It's not only great for cost management capabilities, but also reduces that management overhead of like actually, removing any of those unused or unneeded resources. Think about, your kids turning on a faucet inside the bathroom or something like that, and just kind of leaving it running forever and ever. If you're not on a well like we are, you might get a larger water bill at the end, or keeping the lights on. I guess we all pay for electricity unless you're off the grid. And these latest enhancements provide auto destroy settings that allow you to set things at the project level. So, traditionally, Terraform Cloud and HTTP Terraform had just the organizations and the workspace level. We've added in a project level for divvying up your organizations, and now you can set those workspace lifecycle management inside of the project level, which allows you to kind of think about maybe you align some of those resources that are going to be short-lived into very specific projects, and then anybody who puts a workspace inside of there knows that they have strict lifecycle management inside of there. So these enhancements, relatively new, went GA back in September and generally available now. Do you want to take advantage of all these wonderful lifecycle management tools in HTTP Terraform, but you've got an extensive library of Terraform community? No worries. We've created a tool called Terraform Migrate to help you easily bring that existing community-based infrastructure over to HTTP Terraform, and including some of those lifecycle management features. It was previous to do this tooling, doing that migration was kind of a lengthy process, but we've made this a lot more push button. So Terraform Migrate is going to be released into public beta, or is released in the public beta, and it will provide automation for workspace setup, state migration, and even give you some examples of backend code migrations, again, to help you accelerate the capability of using some of those lifecycle management tools within HTTP Terraform. And if anybody's hung out with me or met me in the past or listened to the beginning of this webinar, I'm a huge fan of our Nomad product. A lot of that stems from the fact that it was an early adopter of Kubernetes. That complexity isn't always the best fit for a lot of organizations, especially those who are strapped for resources. And so Nomad's a great option for folks looking for an application scheduler, but maybe don't need the overall complexity of a Kubernetes environment. And so I personally think Nomad's probably the unsung hero of application scheduling. I can't, I can't explain how many customers come to me and say, we do these really, really amazing things for Nomad. And I ask them to do HashiConf sessions for this because it is really, really quite capable. And now, along with my gushing about Nomad, we do have the ability to assign quotas for GPU workloads, and this solves for key use cases for organizations with really computationally intensive tasks like AI fine tuning or machine learning algorithms, scientific simulations we see used quite a bit, and video processing on those GPU systems. And so in these scenarios, being able to schedule those workloads to multi-instance GPUs and then set quotas for allocation so that we have good utilization and optimization for those workloads that are available to you. So GPU quotas will be generally available in Nomad 1.9. If you're not running with Nomad, give it a chance. It's really a great tool. Next up on one of our my other favorite additions to our portfolio stack is our application identity or internal developer platform tool, which is called Waypoint. And really what Waypoint does is it solves for that intersection of concerns between your platform teams and your developers. The concept of templates make it easy to provision infrastructure on day zero when an application is first deployed. And add-ons make it easy to modify a configuration to address the changing needs of a workload. And so, the previous iterations of Waypoint really, again, focus on those day zero operations. And then we've extended with add-ons. And then lastly, the actions that make it a little bit more easily to continuously manage the life cycle of applications with things like rolling updates or schema changes or anything that's out there. So think like once you've deployed self-service infrastructure, but you might have some regular automated tasks that you have to perform. Actions are really how you perform those on the back end. All right, so you see that all these announcements fit into, we're trying to really accomplish all these solutions around infrastructure lifecycle management. You want our organizations to let your developers move as fast as possible and focus on innovating with their software as opposed to focus on the management of those infrastructure assets as well. So just a quick recap. So we've got HTTP Packer, CI/CD pipeline metadata. That's generally available now. HTTP Terraform stacks in public beta again for any of those HTTP Terraform users. We've included the capabilities around module lifecycle management and ephemeral workspaces, and then added in this beautiful tool of Terraform Migrate to help folks get those community workloads into our enterprise products. One of my favorites, those Nomad GPU enhancements. Anybody have any AI targets inside their environment? Use Nomad for maybe fine-tuning some of those AI models that you have. And then lastly, allowing more self-service operations with HTTP Waypoint with the templates and add-ons and the HTTP Waypoint actions. All right, let's keep going on to the security lifecycle management suite. So a bunch of that we have inside of here, looking at the inspection side of things with HTTP Vault Radar, a bunch of different additions inside of there. We'll talk about some of the additions to HTTP Vault Secrets, Vault 1.18 being released, and then we've got a really cool capability within Boundary called Transparent Sessions, and then in addition to Console called DNS Views. So we're going to jump right into it. The evolution of infrastructure protection has traditionally fallen into two lanes. So that's the reactive security that cleans up after finding mistakes, which allows for speed, but has inherent increased risk inside of there. And the kind of traditional, I guess, castle mode approach of thing, which we call gatekeeping, which basically blocks everything from the beginning and maybe poke holes inside of your environments to allow those applications and users to communicate. However, modern automated operations allows for security to be a little bit more baked into the entire application delivery chain. And that's where we're really focusing our attention, is to really help folks modernize their security footprints inside the cloud and inside of their automated data centers. Much like our focus on lifecycle management for infrastructure, we're also very focused on helping firms both to inspect, connect, and protect their application assets with our security-oriented projects, Vault, Boundary, and Console. And the reason for our shift into lifecycle management focus is due to some critical changes in just general IT operations. One, IT estates are moving from static to dynamic cloud environments, which have different types of network boundaries and other challenges that come along with that. And we're moving from that castle and moat approach to a more identity-based approach for allowing our applications and our users to connect to things. There's a lot more investor and regulator scrutiny on cybersecurity risk and how that has an impact to your business. So a lot of external pressures, making sure that our businesses are safe to run those workloads. And then these challenges often put teams in a very tough position of having to trade off between developer speed and innovation and for higher levels of security. So how do we keep those trade-offs in a way that allows you to have your cake and eat it too? And so really our aim is to make security a lot easier to bake into your delivery process. How do we allow for the capabilities of shifting left without actually stressing out our users in the long run? Okay, so 90% of the breaches are due to leaked credentials, and having a more code-oriented approach to application delivery and sort of managing those credentials at scale is an increasingly difficult task. And so where we've really focused our efforts are in this concepts of security, our secrets lifecycle management, and that journey generally starts with first finding those exposed secrets so that you know where your risk is inside your environment. And then once you've found those things, typically static secrets, you move them into a well-protected secrets management. And then adopt a more fine-grained control with rotated and then moving into things like just-in-time secrets or dynamic secrets that we have. But managing this lifecycle at scale is somewhat of a daunting task. And so really what we're focused on is enabling the automation of all these particular capabilities. A very, very common ask from our customers is that they want us to help them find where those secrets exist outside of a secrets manager like Vault in the first place. And so, almost every Vault conversation I've had over the years that I've been here at HashiCorp starts off with, hey, can you help me find these things? And so we've actually created and we had an acquisition from a company called Blue Bracket and then integrated it into the Vault product suite as HCP Vault Radar. So yeah, this product helps you sniff out where that risk lies, and it's currently in public beta, and we're going to talk through some of the additional features that go along with this as well. So many of our organizations are sensitive to where the scanning is happening. And I think Pershi, hopefully I said your name right, is asking the question. That's why I kind of punted this with this. So now we actually have a radar agent so that organizations can scan their developer resources in their own environments and then review the results of secret findings in the cloud with their HCP Vault Radar dashboard. And just from a technology perspective, don't worry, we're not passing the actual secrets themselves. We're just providing you with a metadata list of where those secrets occur and have hash values that kind of let you know if there's any duplication or anything inside your environment. If on sort of extending that to help your developers take the easiest path to securing their applications, we're adding in pre-receive scanning, things like a pre-hook to the way that you submit your code into your VCS systems. And this really allows those developers to be notified when they've embedded secrets into their applications before they're pushed into those VCS systems. To complement this capability, in the case that a pre-receive hook misses something, we've included remediation guidance for how to properly secure those assets. So should they slip through those initial cracks, I think pre and post processing for helping folks remediate any of those secret leaks that we have. Moving on to HCP Vault Secrets. HCP Vault Secrets is our fully managed Vault solution, and it looks a little bit more like a typical cloud SaaS service. At HashiConf, we announced a few key things. One is general availability for HCP Vault Secrets and added in the capability for auto rotation. Auto rotation helps firms reduce the complexity of doing that rotation while allowing for the flexibility to rotate by specific sets of policies or break glass functionality with on-demand rotation. So if you notice a breach, you say, hey, rotate all my secrets. We've got a push button way of doing that. And we're absolutely happy to integrate this rotation capabilities with core technology providers like AWS, GCP, MongoDB, and Twilio. And much like the HTTP or the Terraform provider module, HTTP Vault Secrets helps abstract the integrations with our technology partners by using trusted relationships through technologies like OIDC. So integrations are a first-class concept in HTTP Vault Secrets, allowing for that more intuitive workflows around secret integration. So think about being able to do things like manage Terraform, right? Rotation's a greater fit for these kind of longer lived workloads. So you think maybe more of your traditional workloads that you have. But Dynamic Secrets really provides for that capability to create and vendor credentials in a just-in-time manner. It removes the need for rotation and really greatly shortening the life scope or the lifetime of any of those secrets that you have and allowing you much more fine-grained capabilities. So if you're looking to adopt more like NIST zero trust type of capabilities where you're constantly interrogating whether or not applications should have connectivity to the endpoints, anytime an application comes alive, it reaches out and grabs a secret from Vault. But actually what Vault does in the back end is that it connects to the end resources like a database. It inserts the username and password into the system. And then when that dynamic secret lifecycle ends, it automatically removes it from those endpoints. So think just-in-time secrets, but also the removal of those secrets over time so that they just don't exist in a system and you can't get leakage of those. Somebody gets a hold of a dynamic secret, say like a week after it's expired, who cares, right? It's no longer viable within those environments. So available as a public beta inside of HTTP Vault Secrets. And are you tired of managing cloud credentials? I saw a couple of folks who are Terraform users. One of the challenges that comes with Terraform is that you have to be able to authenticate and authorize with the clouds or the SaaS providers that you're actually managing. But have no fear. We've allowed for that same concept of dynamic cloud credential workflows with a very tight integration between HTTP Vault Secrets and HTTP Terraform. So think of your workspaces are able to retrieve a set of dynamic credentials directly into those Terraform workspaces, really making it easier for developers to have that secure first mindset with the way that they provision their application infrastructure. In addition to investing in our lifecycle management capabilities, we've also been investing in enterprise capabilities for HTTP Vault Secrets as well. So we've launched resource level role-based access controls so that you can set access levels based off from some kind of an application confidentiality metric, and then we allow for things like secret reader and app admin and some other roles inside of there. We've also introduced audit log streaming, so you can take all that historic data and then put it into maybe a SIM or any other processing systems, so you can go back and report on compliance and like other regulatory concerns. And because this is a core capability for HTTP in general, you'll be able to leverage these in other products like Packer and Boundary as well. So again, HTTP, the HashiCorp Cloud Platform, allowing for that holistic, sort of single pane of glass for managing a wide variety of applications inside that portfolio. So, again, if we think about overall security lifecycle management, our Boundary product is a way for your users to get connectivity to any of your cloud or data center endpoints, much like a traditional PAM type product, but very different in the fact that it's a proxy-based mechanism. So we allow your users to connect to their existing IDP, and then we proxy those connections to any of the assets that they have access to through a dynamic host catalog that we can help you maintain through a set of rules engines. So think like an auto-scaling group inside of AWS, or even like Kubernetes endpoints, because those things could be rescheduled across a wide variety of hosts. How do you allow for those users to connect to those endpoints without having access to the network environments in which those things live, and B, having access even to the credentials in which you need to connect to that? So Boundary can help proxy those connections in a very, very secure way in highly dynamic environments, and supports some of those static environments as well. So think of things like, how do I streamline SSHing into any of known hosts that we have? How do I connect to databases? interfaces, and even how do I connect to, maybe some of the networking devices that exist inside of your existing data centers. So there we go. So proud to announce that the Boundary Transparent Sessions is now in public beta. And really what Boundary Transparent Sessions does is it makes it much, much easier for folks to consume Boundary in general. So previously, you'd have to like go into Boundary and look up any of the hosts that you had access to. You'd have to like copy and paste any of the connection details into your browser or into your command line interface. And so it was kind of a clunky way of interacting with that. Transparent Sessions greatly simplifies the ability for users by just having them log into Boundary and then using the existing tooling and workflows to connect to their endpoints without having to dig through the GUI or CLI to determine what they have access to. We do this by getting in the DNS request stream, like technologically, basically it's sort of like a midstream DNS provider or a resolver, and then we automatically map that to any of the host endpoints dynamically. The important thing, of course, to remember is that users will only be able to connect to anything inside of the dynamic host catalog. So Boundary's getting this major upgrade at HashiConf with transparent sessions, again, available in public beta. Just kind of overall reducing the complexity for how it is that your users manage this. And so again, just this is something that's been in the plan for about a year. One of the designers or developers told me about it last year at HashiConf, and I told him I wanted it as soon as possible. Obviously, quite a bit of engineering effort gone into this. Again, greatly streamlining the ability for you to use Boundary. So those are just a few of the announcements from the platform. The security lifecycle management portfolio has really been driving some significant innovation inside of there, but we also have a couple of extra capabilities that we have. One, adaptive overload protection for Vault. So the idea of being able to not take Vault down when you have a thundering herd of connection requests that are coming in here. We're innovating in the PKI space. So the CMP v2 protocol used largely in 5G operations, so automatic distribution of certificates for those environments. And then we've added the ability to do IPv6 capabilities within the Vault tooling as well. Console introduced something called console DNS views, which just kind of allows you to only do DNS queries inside of sort of like a namespace in which you have capabilities of. So again, just kind of reducing the visibility with your application environment to increase the security inside of there as well. On the HTTP platform itself, we've introduced more fine-grained application level RBAC, and then of course the audit log streaming that I mentioned before. So again, just a couple of the additional features that I won't be digging too much into. So if I were to recap the security announcements, we've got HTTP Vault Radar in public beta with adding in the hybrid agent. Hopefully that that answers some of the questions around self-hosted inside of there. We've got some of the prevention workflows and remediation guidance inside of HTTP Vault Radar as well. HTTP Vault Secrets maturing in the areas of auto rotation and dynamic secrets, and of course integrating with HTTP Terraform to allow for dynamic-based cloud credentials. Vault 1.18 is coming out, and then we've got Boundary Transparent Sessions, and then those console DNS views. And so how are we doing? Oh, geez, I got it right at 46 minutes. Thanks everybody for attending.
Yeah, that was awesome, Jake. Thank you. It was a great session that summarizes the HashiConf announcement that happened in October. If your organization is looking to implement HashiCorp suite of tools for infrastructure lifecycle use case or security lifecycle use case, this video from Jake could have provided insights on various solutions HashiCorp recently introduced in HashiConf 2024. So here comes the next talk. It is test-driven delivery of infrastructure as a code by Kamalika. Over to Kamalika.
I'm Jake Lundberg. I'm a
Welcome to HashiTalks India. And today's talk is going to be about test-driven delivery of infrastructure as code. And we will be understanding how to test infrastructure as code, especially Terraform code, using two of the tools, both for unit test and integration test, and how to structure it and how you can get the benefits of testing infrastructure as code. So let's get started. First up, why test-driven delivery, and why do I call it test-driven delivery and not test-driven development, or TDD, which is the common term used for application testing. First off, for infrastructure, we all know that until and unless it is being tested or used, we really don't know whether the infrastructure has been created properly or not. So first off, test-driven delivery, because it has to be delivered, even if it is for development purposes or for testing purposes, it has to be delivered to the users so that it can be, you can see how it works. So first up is reducing burden on application development cycle. So if you do not do test before delivery, you will be imposing more burden on your application development cycle to also test your infrastructure. Let's say you are creating infrastructure for your development purposes, and you do not have test, or you do not do test, or you're dependent on manual verification through your console, etc. Then you will have to wait until your application is deployed on that infrastructure to see that every requirement that the application has from infrastructure is actually satisfied by the infrastructure scope. So that means your infrastructure development cycle increases, and it puts extra responsibility on the application development cycle, because then things can fail in application due to the infrastructure. So that is why it is better to do test before you are delivering the infrastructure, so that you reduce that infrastructure testing burden, because application already would have a lot of testing scenarios. You do not want to impose even infrastructure testing on the application development cycle. So that's why reducing burden on application development cycle. Second reason is maintain production sanity. It must work from dev to prod. The whole reason of the entire DevOps movement 10 years back, or more than 10 years back, was because we were facing issues in developing and releasing in production. We would see a lot of production issues. We would see common scenarios like things in development, but it fails in production. So maintaining production sanity is very important, and that is why you need to test more and test early, especially infrastructure, and reduce testing, or do no testing on production at all. You need to be absolutely sure that if you're doing any upgrades, any new addition to your infrastructure, it should work in production and it should not break production. So maintaining production sanity is important, and that is why you should test before delivery and do test-driven delivery. Third is zero downtime updates. We know technologies and updates keep coming in every month and sometimes even weeks, especially if you're using cloud. You would see that the cloud providers release, to keep up with the latest technologies, they also upgrade their technologies. Let's say Kubernetes releases almost every month. There is a new version every month. And in line with that, even the cloud provider will upgrade it. So you will need to do regular updates, and it's more and nowadays it has been become more frequent with the extend or with the extension of softwares and newer software coming in. So you cannot afford downtimes every month for your production or even your development. If your developer is stuck for days because of a version upgrade, it really hampers the entire release cycle. So that is why zero downtime updates is possible only when you test your infrastructure prior to putting it in the development, in the application development cycle. So for these zero downtime updates. And the last 3 points, it is really not possible to mock everything like in application development, where we do TDD, which is test-driven development, where you can mock application features and write tests to fail the application. In infrastructure, it's slightly different. It is not possible to mock an entire AWS's VPC on your network. You would be able to mock it as per behavior, but not the exact configurations that AWS have. And you should not and must not run tests in production. And hence, I call it test-driven delivery instead of test-driven development, because it's not just developing or writing the code. It's actually testing before you are even running, even you're executing the infrastructure as code. So delivery starts from day one of your infrastructure as code, and hence I call it test-driven delivery. So what do you know? How do we do test-driven delivery or test infrastructure as code? You need two things. First up is environments on demand. Environment on demand is a setup where you can spin up environment, do changes, and then it can be decommissioned or recreated at any time within minutes. Basically, a dynamic set of environments which can be brought up, and it can be as close as possible to production, and it can be tested, and then it can be brought down. This kind of environment on demand enables you to have faster testing cycles and faster delivery cycle, because then you can do performance based auto scaling and continuous delivery, and in fact you can also test backward compatibility. So this is very important, that you can spin up and spin down environments on demand so that you can test them, and at the same time you can also have a balance on your financial expenses on cloud, so that if you do not have it, you will have to retain an environment for a longer period of time just to test it. But if you adopt the concept and if you write your infrastructure as code with respect to creating environments on demand, then you have the flexibility of creating an environment within minutes, doing all the tests, be it performance, it can even be security testing, and then satisfying it, exporting these configs to production, and then you just retire that environment. And so you can do testing on demand, and you don't have to spend a lot of money on the environments. The second important thing that you need for test-driven delivery is modular infrastructure or modular infrastructure as code. You should not just automate. Nowadays, writing infrastructure as code has become very easy with Terraform because it's a DSL. You do not, you don't have to absolutely have programming, experience. You can get started on day one, and it's pretty easy to get onboarded. So on one hand, Terraform makes it very easy to start infrastructure as coding, but you should also follow some of the best practices of how to write Terraform, or what gives modularity to your infrastructure. So don't just automate or write everything inside one piece of code repository and put everything inside it. Try to modularize and parameterize your Terraform code or your infrastructure as code, whichever tools you are using. Make sure you can separate or segregate the units which are reusable or which can be reused in different parts of your software or your projects or your organization. So segregate the code into reusable modules, and even Terraform follows that. If you have seen Terraform registries, it has a concept of modules for individual resources or services that the cloud providers or whichever provider we are using. So segregate the code. We'll have to segregate the code into reusable modules, and then we'll have to create deployable environment specific provisioner, which are also modules. So I call it the module and provisioner setup or modular infrastructure as code. So I create modules and which can be tested individually as units, or we call it unit test. And then we have provisioner modules, which can be which are the integration of all these modules into the actual environments where the software is going to be delivered. So let's get into some demo, and let's see how this works in real life with Terraform code. So today's demo is going to be with Terraform for infrastructure as code, inspect for unit test of Terraform modules, and TerraTest for integration test of the provisioners or the environment specific deployers. So when I talk about modular infrastructure as code, you can see here is my code structure. So I divide my code into Terraform modules, which are individual units which can be reused to constitute different kind of environment setup. So I have modules separated in different repositories, and the good part of splitting it into modules, individual modules, is that I can test them independently without impacting the entire infrastructure as code or without impacting other environments. Because let's say I want to test network, then I can just spin up this network module, and I can test various configurations within the network. Let's say I want to add an extra gateway, I can test it. I want to add an extra subnet, then I can just add it to this module and I can run my test into it. And sometimes some environments may not need everything that you have, but some may need everything you have. Let's say it may not need your certificate. So ACM, today's demo, I'm showing the code with respect to AWS. So these are all AWS specific modules. So ACM is AWS certificate manager. So let's say some needs a certificate, some do not need certificate. So you do not necessarily have to include everything. If you have everything inside one code repository and do not split it, then unnecessarily you will have to also implement these resources, which is not required by an environment. And plus, multi-tenant deployment becomes difficult if you do not split it into modules, or if you do not create modular infrastructure as code. The next set of module I call them provisioners, and these are actually the environment on demands that we create using the modules which are here. So as you can see, you can have environments. Let's say you can have admin environments, which can have all your centralized admin components. Let's say your VPNs, your CI/CD, your logging, monitoring, your security and SIAM services, etc. So you can have like this, and then you can have your non-production, which can be your dev, QA, staging, and these are separate repositories which you can have. Plus, you can split your production, because it's better in terms of security as well to keep your production and non-production in a separate environments or separate repositories, so you do not impact the production. And this way you can actually, so if you look at my non-production environment, for example, I have a base configuration first, which will create a Terraform backend, and then it will create a public zone, which is the DNS zone, which I'll be using for my environment, for my non-production environment. And then I create the network here. So you can see all of these. So the practice that I follow is that provisioners should only refer to modules, and modules should only refer to resources. And that way I can do changes in one place, and it gets updated in multiple environments, and I can promote it to multiple environments, because otherwise I'll have to go to each environment and do a change. Let's say I want to add an extra subnet in my environment, then I'll have to go to each of them and update. But in this case, if I only change my PF network module, it will be updated in once I test, of course, it will be updated in all the environments. So here, this is how I structure environment on demand here. Now to deploy, let's say even in non-production, you might need multiple environments for testing multiple scenarios. For example, you might need a development testing environment, and you need a user acceptance testing or UAT environment, or you may even need a exact replica of production, which is for performance testing. Because especially for SaaS or online-based services, you would see most often features are released in terms of onboarding more customers. So when you have such kind of feature, you need to test whether your environment is actually performance ready. So in those cases, you need a temporary performance testing environment. So then you can create, you can actually create it in the non-production repository and use Terraform Workspace. So when you use Terraform Workspace for your environment, you don't have to create like a dev repository, QA repository, performance test, which you may not need forever. So what you can instead do is you can have a non-prod repository and use Terraform Workspace within that, and you can switch between environments. So your states are actually separated out within the non-production setup. Now let's look at how it actually works. I'm using AWS, so my backend is S3. So I'll show you how the configuration works in terms of S3. So So first up, what we are going to do is we are going to execute each of these modules step by step, and then we are going to test each one of them using inspect, and then we are going to do an end-to-end testing using TerraTest. So let's see. Let's first look into the unit tests. So first up is base. So before we create the non-prod network, we need to create the backend and the zones for the non-prod network. And in this demo, I'm also going to show, apart from network, we are going to deploy an EKS cluster, and we are going to deploy an application. So we'll test the end-to-end flow of first we'll test unit by unit, like first the network, first the initial backend setup, and then the network setup, and then the EKS cluster deployment. And then we are going to do an end-to-end test where it will show that the application the EKS cluster is successfully created and it can be used for application deployment. So let's see. First so I'm inside my non-prod repository, and I'm going to go inside my base. So you need to do some initial setup for inspect. So I would recommend that you go to inspect's website and see what inspect is based on Ruby. So you need to install some gem files and set up inspect on your local machine, or if you are using CI on your CI agent or Docker containers, whichever you prefer, you can use it. I'm going to show this demo on my local machine, but I will also show you how I use it on my CI if time permits. So first up, once you have installed inspect, you will have to initialize inspect, and when you do test initialization, it will create a certain structure, and you can see the structure that you can see here is it has a verified directory, and then it has an inspect.yaml. So inside the verified directory, you have something called as controls. This is where the inspect resources and tests are written. So inspect is also a DSL like Terraform. So when you are actually executing inspect, you will find the structure is a lot similar to how Terraform resources are. And the reason I use inspect is it generates a good report at the end. Plus, since it's a DSL, it's easier for onboarding. You don't need to have programming background, or be an expert in certain Ruby to write inspect code. So you can get started with inspect for your unit testing. So here I have written an inspect test file inside its control where I'm going to test. So basically in the base provisioner, I'm creating a Terraform backend using ST bucket. So I'm going to check whether the bucket is created and whether this bucket is a private bucket. It should not be public because it will have my Terraform state. So I'm testing whether it is, I'm testing that it should not be public and it should exist. And I'm taking the bucket name, all these values from a file called Terraform JSON. Now, Terraform JSON is being created from the Terraform output, which is run when I execute Terraform apply. So here we go. First, we do Terraform apply, of course, to run the entire setup. So yeah, you can see no changes because I have already run Terraform apply to save some time. So it has executed Terraform apply. Now, once Terraform apply is done, I need to run a Terraform. I need to copy the Terraform output into a JSON file so that inspect can read. So I'm going to I'm going to run Terraform output and export it into JSON format under files terraform.json, which is within the inspect directory itself, which is files Terraform. And this is a standard structure of inspect. So when you are creating inspect init, it will actually create a files directory. So you can use the inspect function profile and then file. So it's actually inside the profile, it will create it. So you can just follow the same thing. So you do this, and now I'm going to run the test. The command is inspect, exec, test, verify. And this is going to check the Terraform output, the .json file, and then validate all the configurations. Okay, so it has failed because it is not able to find my region. So what I'll have to do is I'll have to export my region. I'm using AP South 1, which is AWS region AP South 1. And now I'm going to run my inspect test. Yeah, so you see the test is successful and it has actually returned all the, so the S3 bucket name is this, and it is exist, it is expected to exist, so it is a green, and likewise. And then it has also checked for all my name servers, which are correct, and the private zone, and the zone is public because I'll be using it for my certificates for EKS cluster, so it has tested. So this way I'm able to test unit by unit. Likewise, I will go to my network, and then I've already executed my network. So all I'm going to do is actually copy my output into my file. So once you do Terraform apply, then you have to do Terraform output and copy it to JSON file, and then you run inspect. So inspect, this way you can test module by module, and in fact, you can go one step ahead, and the AWS modules that I have shown here, you can in fact add your test inside each of the modules. It's like an unit test. So whenever you are pushing code inside your network module, it will automatically run your test. You can set your pipeline to run automatically inside your test, and that way you can have the real modular testing. For today's demo, I'm showing it from the provisioner side because I've just structured it to make it faster. So here you see it has failed. So if it fails, it will fail. Here it says that it has to include tags called environment. So probably my tag is different. It is not including it, but it has tested some of the other subnets. So likewise, you can create your test cases and check whether it is actually satisfying your environment or not. Because here, this is how you can test your unit by unit. Now, let's say we have tested it unit by unit. Now, how do we test it? We are creating an EKS cluster. So for our EKS cluster, I'll be running my tests again. And let's see how, when an EKS cluster is created, it is created with, I am also deploying an ingress. So it creates, it deploys a dummy service, which is actually accessible through. So you can see my dummy service is shared EKS ingress. Now, what I'm going to do is in my integration test, I'm going to check whether my EKS, whether the end-to-end stuff like network is created and then the EKS cluster is able to deploy or not. So if I run, so here I'm going to first run my inspect, and let's see. So how do we do integration test? Once you have run module by module test using inspect, you would also want to know the entire flow, whether it is working or not. And for that, we are going to use TerraTest. So this is how TerraTest works. TerraTest needs some bit of a programming background because it is based on Golang. So you need to understand Golang to write TerraTest. But you can fairly use it. So if you see the reason TerraTest can be used for integration test is that it also includes an init apply. So in inspec, we have to apply Terraform apply and Terraform output separately and then run the inspect command. You can, of course, integrate them within your CI scripts. But if you want to run it locally, run the entire end-to-end test, you can use TerraTest using init apply. And then you can create your conditions like, say, URL equal to public endpoint, then HTTP. You can go, and here I'm checking my ingress endpoint here. So yeah, so my setup is EKS is ready. I'm just going to go back to my root, which is my non-prod repository, and I'm only going to run. I'm going to go inside my test repository, and I'm going to run my go command so that it runs the end-to-end test. So here you see that it will. So the reason I chose to use TerraTest for integration test is that in integration test you can test the entire flow in one command. So you can have all your you can go directory by directory, run your module by module, and then it will test the endpoint integration, that your final service, which is your ingress or your application which is deployed on your EKS cluster, is actually working. Once it works, they can give your EKS cluster to your development team, and then they can use it for their application deployment. One difference between inspec and TerraTest is that inspec gives you a nice report like this. The reports in TerraTest is kind of within like the Terraform log. So you might find it difficult sometimes when you're running it in CI, but it serves the purpose. So you can see the logs are actually within. So what I prefer is a combination of both, so that module by module I get a report, and then I can run the entire end-to-end test and get the final, the result where the application is working or not. So you see the final result, okay, test is pass. So it will only give you this. It does not have a nice formatting like inspec has. So you can use a combination of both, but then again, there is a one thing in inspec where you need to apply it separately, copy the output, and then run inspec. So yeah, there are some pros and cons in both, but you can combine both of them and create your test driven delivery pipeline in your CI, which can look something similar to if you're using GitLab or if you're using Jenkins, you can have them within your stages. So herein, this is how your tests can look like when you're doing test driven delivery with Terraform, and you can use inspec or TerraTest, or there can be other tools which can be used. You can use JavaScript tools as well to test if you are comfortable with JavaScript programming. However, for users or practitioners who are not familiar with those scripting languages, I find these two scripting tools are easier for onboarding and serves the purpose. So this is how my pipelines look like. First up, I'll do linting. I did not have time to show that, but linting is Terraform using Terraform formatting, which tests any kind of syntax error in your Terraform. So you can add linting, and then it can run Terraform validate and Terraform plan. Then you can run the inspect test, which is the unit test for every module, and then you can run your Terra test, which is the entire setup in one flow, which is the end-to-end testing, which ends with your like a dummy application or any service which you can curl or you can access using HTTP. So thank you so much. This here ends test driven delivery talk on infrastructure as code. I hope this talk is useful for you, and you can utilize it in your day-to-day Terraform coding, and it helps you in getting some of the issues. It helps you in expediting your development process and saves you time from going from into the console and verifying each and every components after you deploy. So I hope this. You can connect me in, these are my social media links, and you can also take a look at 10factorinfra.com. I write a lot about infrastructure, Terraform, etc. there. So that's all for today. Thank you.
Yeah, that was an awesome talk, Kamalika. So it was a remarkable talk on test-driven delivery for infrastructure as a code, because test-driven delivery improves the error-free code in the infrastructure, whatever we are going to create. Please remember, we will be sharing all these talks on YouTube in coming weeks. So if you are just tuning in now, don't worry, you can catch up later in the YouTube. Now I'll be handing over the MC to Ajit Modi. He is also an HashiCorp ambassador. Let me hand it over to him for hosting the session. Thanks to HashiCorp team for extending the emceeing opportunity for me. Over to Adit.
Thanks, Ravanam, for emceeing for the event. It was really good work by you and the team. Really loved joining you and also listening to you and the amazing speakers we have for today. Hi, everyone. I'm Adit. I'm an HashiCorp ambassador from Vadodara, Gujarat. And I also am part of HashiCorp user group. I organize the Vadodara chapter. I work as a solution architect at Lauren. We are an AWS Advanced partner, and we specialize in DevOps and infrastructure as code. So we do support DevOps and infrastructure as code to our clients, including Terraform and other HashiCorp suite of products. It's great to have many of you join us here today. Let us know in the comments where you have joined us from and what are the sessions that you are finding amazing today. What's new insight or learning that you have found from these sessions today? Do let us know in the comment section as well. So moving on, the next speaker that we have today is Kirtivasan Kannan. Kirtivasan works as a senior DevOps engineer at Mandera. He is an 5x AWS certified and also an AWS community member. He has 9 years plus experience in the industry, and he also runs a YouTube channel which has 9K plus subscribers. He posts videos in the Indian languages. In this session, Kirtivasan is going to deep dive into streamlining infrastructure deployment using Packer and Terraform. We will learn how to build tailored machine images with Packer and seamlessly integrate them with Terraform workflows for efficient infrastructure provisioning. So over to Kirtivasan now.
Good morning, good afternoon, good evening, based on which part of world you are watching this series. Welcome everyone for today's talk, which is on streamlining infrastructure deployment using the two fancy tools, Packer and Terraform. Who am I? Why I'm speaking this? Myself, Vasan. I'm senior cloud and DevOps engineer as part of an organization in Mahindra, and you see the LinkedIn link, which is a Kirtivasan Kannan, which you can follow, and for any follow-up questions, you can leave a ping over there. I'm also hold 6 cross AWS certified, and I also hold fancy Terraform associate certified person. In my part time, I do run 2 YouTube channels, one eVidai and the another Tech Page. So both is around AWS, DevOps, Terraform, and fancy technical topics. One in the Indian regional language Tamil, the Tech Page, and the other one it's in global English. So if you haven't checked it out, I would highly recommend to check it out and do follow. So today's agenda. So these are the whatever you see in the screen. So we'll talk about the infrastructure. What is infrastructure? How we can automate it using infrastructure code. So when we say code, it's not a real-time programming language. It's going to be like a couple of syntax which HashiCorp offers. And how can we use Packer to configure our infrastructure, and also like how we can streamline it using GitHub Actions and few best practices that to be considered when we streamline this. So that's going to be part of today's agenda. So without wasting time, let's deep dive into the session. I also have a couple of demos planned in middle of the session, and also I'll be sharing the GitHub repo for the entire demo code which we do using Terraform, Packer, and the GitHub pipeline. So you can still go back and try to get your hands dirty post session. Since I come from the AWS background, so I have listed a few services which represents infrastructure. In other cloud, it would be more or similar. So you have S3, For example, in AWS for storage service, you have cloud storage in GCP, likewise the other in the Azure. So we have EC2 instance, we have Lambda, you have EKS and SQSSNS and more. So these things we generally call it as infrastructure, right? So we procure a cloud infrastructure to host our application. We do fancy serverless, server based, and more. So out of all these infrastructure, so generally we can create infrastructure using either infrastructure code like Terraform or the cloud native providers like CloudFormation and more. But what today we'll be focusing on the service is EC2. Okay, so so this one we spoke just now. So the infrastructure code. So why we want to do as infrastructure code, as many would have spoken in today's session about Terraform, it's to track your change. You can easily replicate in multi-cloud and you can automate more on that. So yeah, so first we'll start with Terraform. Obviously, Terraform is going to support multi-cloud. You can write code and then you can use multiple cloud management into a single repository and play with it. It's not just limited to cloud. It also offers you like other providers, like you have Cloudflare, you have Azure Active Directory and Kubernetes, like few to mention, which is not cloud. So Terraform is not just meant for cloud, but you can automate even, you can write your own custom providers if you're developing a product for Terraform using a Go language. So coming back to the infrastructure, as I was mentioning about infrastructure, like it's not just about creation of infrastructure. The peculiar service which we today will take as use case is the EC2 instance, where we just not create infrastructure, but we also configure it. So when we configure, I say is that we would need certain, let's say if you're launching an web server, Apache server, then we might need to pre-install the Apache server when we boot so that the server can be up and running, or we might need to create some log file configurations, or we might be having a custom requirement for our own application use case, which we want to keep it ready. So those things we call it as configure. And today we'll see how we can use Packer in terms of to like pre-configure and how we can bake it, how we can use it in the Terraform world, and how we can pipeline it. So that's going to be the entire session. So for creation, we'll be using the Terraform. And if you want to create a EC2 instance, the web server or server in the AWS world, you need to use AWS_instance resource type, and bare minimum they would expect this two specific field to spin up your instance. And obviously, like you would be adding the provider configuration to say like what provider, which region your EC2 instance would be created. On scenarios of spinning up an Apache instance, let's say Apache server, then you would be also passing the user data to it to get this server up and running. Okay, so let's see how we would be writing a Terraform code and how we would be running it, and how we can spin up the EC2 instance quickly. So it's a demo time. Yeah. So what I have a folder called infrastructure for this specific purpose, where I have written a main.tf, which I showed just a couple of seconds back. So where we have a resource, the resource type is AWS instance, and this can be any naming. It's a unique identifier. You can keep it Watson server, web server, Apache server, or any. And then we'll need to pass the AMI value, the AMI ID, which is going to be the base OS, right? From where the instance will be like using it. Is that Ubuntu? Is that a custom AMI with custom packages? So based on that, we'll be choosing it. And instance type, like based on our use case, based on our CPU need, and the T2.micro is the minimum we can go for it. And the security group, it's to allow like what ports we allow, from which source IPs we allow. For demo purpose, I created a security group already, which is allowing the port 80 from overall traffic. And I'm using the user data for now, so that we would be installing the Apache server, and we'll be writing an HTML file. And as an output, once the server is created, we'll be printing out the public IP so that we can go to the browser, hit it, and see are we getting the message hello Apache is running or not. And obviously so added the provider configuration. So since for demo, like I kept everything in a single file, main.tf, but for ECDWT, we can split into like multiple files like provider.tf and output.tf, and if you're using any data block, data.tf and more on. So today's primary focus is to like spin up an EC2 instance with an AMI and see how quickly we can do it, right? So I already configured the credentials. So if it's the access key, I already set it in my local machine. So all I'm going to do is the cd infra, and then so here we have our the main.tf file, as you could see. And first thing you would do is to initialize the Terraform so that all the providers. So provider is the integration between the API and our code to see like what resource will be created and what we are asking it to create and what type of resource and credentials, right? So those things to enable the communication between our code to our account or to the service, we use provider, and we are initializing it. And the next one is to see what our change is going to do. Are we going to destroy the existing resource, or are we going to create a new one? What is going to happen, right? So we'll be getting those details by running Terraform plan. So you could see that we are creating an EC2 instance with the AMI, and details are like what are the details will be like applied. And to make our life easy, like rather going to the console and looking for like what is the public IP of the server, I'm printing it out. So once the server is created, we'll be getting the public IP right instance in the terminal, and then we can go and hit the browser to see whether the server service is up and running or not. Right, so let's apply the change. So if you do apply, it's asking for the confirmation. Let's give S, and so once I give S, it's going to call the API to see like, hey, I'm going to create a EC2 instance of this, and this is the AMI I'm looking for it, and get it on created. And if you see, the server instance created, and we also got the public IP of the server. So if I go to the browser and if I hit the public IP, so by default it's going to HTTP, and we see the output which is hello, the Apache is running, right? So we can also cross check in the console. You'll be able to see an EC2 instance is spinning up, running, and the same public IP exists over that. So it's very bare minimum in terms of creating an EC2 instance, using user data where to launch the server, and then we just hosted a centralized index.html file, and then we also allowed the port, right? So if I told that we already created a port which is to allow port 80, and we are allowing the source 00. So to delete the instance, again it's straightforward, right? So we just do Terraform destroy, then it's going to delete the server or delete the instance for us. So let's give yes, and boom, so it will get destroyed. So that's the more power of infra's code, where we create once we have the base code ready, right, and the template or instance ready, then we can create it within fraction of seconds and destroy it within fraction of seconds. So this can be like helpful in terms of cost saving. Like if you have a non-prod instance, you might need to shut it down like Friday evening 3 o'clock and then bringing it up Monday morning 9 o'clock. Then you can schedule it as a job, so that without any manual interruption, you can still save the server runtime building part, right? So let's wait for it to destroy and let it destroy in parallel. So let's move on to our demo part, right? So we have seen how we can create an EC2 instance, how we can use the user data to launch the server itself, and then we also evaluated is the server is up and running or not, both by hitting the public IP, and also we checked ourselves in the console, and also we have seen how quick is to destroy the server, right? So if you see the user data, so I went a bit quick in terms of like you would have hardly seen like a couple of lines. So if you see, like we ensure when the server is spinning up, we are updating the package, and then we are installing the Apache. That's what the systemctl start HTTP does. And then we also creating a file, the index.html file, which to be get indexed whenever the default slash path is being getting called, right? So in real world, you don't need to, you're not going to limit within this. You might be having some custom package like Java to be installed or Python to be installed, or you might be having custom application packages, which can take a lot of time, right? So in our case, it's quick, but what if it's taking like a lot of time, or you want to standardize, say I need to everyone to use a specific version of a Java or a specific certain standard to be maintained across all the organization, then that's where the key centralized configuration pattern comes in, and that's where we move from here. In this case, like let's say if you want to launch like 10 different instances, these are like repeated part where you are going to install, so it's going to take a bit of time, and then you're going to the starting of the one which should be do at the server level. So we can move the repeated process where the installation, where we think the time going to happen, or it will be helpful if it's like pre-installed. So those things can be achieved using Packer. So Packer is a tool which helps us to create an standardized AMI. So in industry, many calls it in different name. The standardized AMI, a few call it as golden AMI, a few call it as pre-baked AMI. But ideally, what they directly translates is you create an AMI, which is Amazon Machine Image, or the similar, the pre-baked OS, from where you can spin up your instance, where you can standardize the image so that the standard is being set, like what packages should be come and what's allowed, so that no new tooling gets into your server without your knowledge, and by which you ensure your security is being enforced, and so and so. So how we can do it with Packer? So in Terraform, it was quite easy. Like we see the resource block, we see the provider block, we see the output block, and we ran couple of commands, we spin it up, and we ran destroy to destroy it. So Packer also, it's quite similar. So we have the Packer required plugins, which is equivalent of providers to see like where it's going to communicate. Then you have the source block, of which like which AMIs should be taking as a base image, and from where you are going to run your custom command. So whatever the pre-installation command is going to be imagined as a own layer, and on what OS these commands should get ran or executed. So in this case, you are using filters to say like, okay, this is the base image I need to get filtered, whichever is following this category, and which region I'm running it. So in this case, it's been mentioned US West 2. You can use EU West 1 based on your use case. And then the major thing is the owners. So owners is the AWS account, not your AWS account, but each AMI from where the base image you are going to use. So that base image where it lies, that specific account you need to be providing here. Yeah, and then the other factors are like more self-explanatory, like this AMI is going to use in what type of instance, what region it should be created, and what is the AMI name you are going to use for this. So everything is like straightforward, but what you need to keep in mind is that the owner's account is the actual base image owner's account, not the account where you're going to execute a command. And then the build block. So the build block is where you would be mentioning in terms of what are the commands or what are the packages should be get executed as a default within your base image. So what goes in inline? So if you recall, few minutes back, we talked about Terraform and user data. The M block, the echo block are like more repeated structure. So if you want to pre-bake it as an AMI, so those blocks would go into the inline piece, and then we will be building up the AMI out of it. Okay, let's see a quick demo of how it would look like in real world when it comes to Packer building an AMI part. Right, so back to the code. So I create a file called Packer, and the Packer follows the file extension .pk or .htl. And I missed to mention, like the Terraform would follow the extension .tf, and the packer is we use ami.pkr.hcl, and same as, so you can use variable to refer, set the values, and then you will be referring those variables using var dot the variable name, so that the values get fetched from there. So packer required building, so based on what API you're going to use. So in our case, we're going to use AWS. So I'm using the plugin for the Amazon part, and everything is available as a document in the Packer website. So based on what cloud provider you're going to use, you will be using that. And so this is also, again, the documentation is readily available from the Packer website, where we're using the source Amazon EBS, which is we're creating an AMA for Amazon cloud, and this can be anything. It's just for our reference. So you can name it as Ubuntu, you can name it as web server as part of it. And so I have declared the AMI name as Wasn't Packer demo. Maybe I'll keep it as one hyphen, because that should be already one I created. So just to differentiate, I'll create it like demo -1. And the build is where we inline commands, like what are the commands that should get executed. So about this one, I will come back in the upcoming slides, but it does pretty much the same, but you would see something varying than which we did in the user data. I'll talk about that in the upcoming few minutes, like why we ended up in this state of inline, why not just doing the same as we did in the user data aspect. And so that's more about it in terms of the packer itself. So to do the packer, so you go for the folder, sorry, packer. So you can use packer initializing factor, so that all the plugins, anything you have in place, that gets initialized, and then you can validate the packer using packer validate the file name, so that it's checks if everything is fine in terms of format, in terms of values that you would expect. And then to run it, so you would say packer build and then the file name. So to build, it takes a couple of minutes, say in my case it took something around like 10 to 12 minutes in generic. So we'll also go to the console and see the AMI page. So you'll be seeing somewhere here there is already one exist, which I tried creating for testing purpose. So instead of demo, it should be like demo-1. A new AMI should get created post successful run of this job or this run. So let's wait for it. All right, so the base image is created, and the pipeline says like it's waiting for AMI to become ready. So if I refresh the console, we could see that the new AMI which we created has been created, which is demo-1, and it's still in the pending stage, and it would hardly take another 5 more minutes to bring it be available. So you might ask like, hey, when we run Terraform and user data, it was like quick, fast, but then using this AMI, it looks like time consuming, but it's a one-time activity. And if you think in terms of bulk server where you want to standardize centralized AMI, this not only help you in terms of the time consumption, plus also in terms of standardizing the AMI. So both in terms of security and time consumption, this the pre-baked AMI would come handy. Okay, so in parallel, let's let it go. In parallel, I will show you like how we can streamline this. So we have seen two different things: the Terraform for running the resource creation of server, and then the Packer for pre-building the AMI. And to streamline this, we can use GitHub Actions. So if you see, I have created a repo infra streamline. Post this session, I will make it public, so that you guys can go and refer the code if you're interested. And I'm using three the SS keys for the GitHub Actions to run, and I have placed the workflow in the .github workflows path. Let's quickly go through like what I have written, and then we'll take it from there. So I have said like on main. So whenever I'm publishing any new changes to the main branch, it's going to trigger the GitHub action. You can also play with it in terms of pull request to main, or any future branch with a keyword. Like GitHub action supports a lot of multiple approach to trigger it. And then I'm using the native option within the GitHub Actions to clone the repository to the running server, so that it knows what code file we have in place. And I'm setting out my AWS credentials to the local machine. So if you are using GitHub Actions using your self-hosted runner, and if that runner is from AWS instance, then you can use the IAM role itself. You don't need to set this credentials part. Since for demo I'm using GitHub Actions personal account, so I'm using this temporary credentials for the demo. But in real world, you would be using IAM role, so that you don't need to worry about these credentials, and that IAM role will be assuming some other like standard IAM role part of it. And then I'm installing the Packer here, and again same as you see in the previous demo, like I'm running the init image and I'm validating the package. And ideally this one would be doing a building process. Just for demo purpose I commented it, because it takes like 12 minutes of time to build it. And then we can also run the Terraform part by initializing the Terraform, validate it, and then apply it in the on the fly. So let's see how it would look like in real world. And what I'm going to do is I'm going to comment the user data. No, I'll keep the user data, but I will remove these files, EOF. So for that, and I'm moving this line and this one. Okay, so let's check it now. Now it should not complain, and it should go through in terms of initialize phase. And let's see. So it's configuring the credentials, Packer is done, initialization is done. Yeah, so the Terraform init has been successful. Then it will be validating our Terraform code. The validation is done, and you see it's doing the Terraform plan, and the instance is getting created. So we are pipeline the process in terms of baking the AMI, and so we also got the public IP of the server. So if I hit it, you see we created the server using the pre-baked AMI, and the server is up and running. And if you see in the console as well, this is an AMI, and the instance, there should be one instance picked up. Yeah, you see it's running, which is the instance which we created using the pipeline part. So yeah, we have seen like how we can do it in the pipeline part. So here for demo purpose, I kept both in the same repository in terms of building the AMI and creating the resource. But in real world, you would be using like building the Packer using a centralized repository, and then using Terraform data block. You'll be using the AMI ID reference here instead of directly hard coding it. You would be using data block to refer it, so that using filters you can get the latest AMI value and streamline it. Yeah, so this is generally how we can streamline using GitHub Actions and Terraform to create a resource, and Packer to create the pre-baked AMI part. So few best practices to keep in mind. So always it's good to keep the AMI creation process in a separate repo, not merge it with where you actually create the server, unless you have a requirement that an AMI should be created and then server should be created, maybe test instance or something like that. Because the ideal reason of AMI is to like to use that wider audience, right? That's where the golden AMI or pre-baked AMI comes in. And if you want to make your instance wait for each time of AMI creation and then do it, it can be a bit lengthy process. So that you can consider in mind in terms of doing it. And you can try to containerize it, the entire process. If you recall, I was mentioning about why our user data and why our this specific thing is like a bit quite different, right? So if you see in the code, we used somewhat different in terms of the sudo stdi app part and stuff. It's because that we were using here the base image as Ubuntu, and the packer which we ran, it was running it locally in my system, which is Mac OS. So when I was executing it, and how the way, like how the uh, local machine was handling this was completely different. So when I tried locally, I was using the same command of how we did it in the user data, and it works fine. But then when we wanted to use the Ubuntu latest one as a base image in the GitHub action, run it, there were like certain hiccups being came through. So to regularize it, we can try to containerize it so that the command remains constant. Either you test it locally, you run it anywhere else to maintain the consistency aspect, like how you deploy it, right? So rather deploying it using directly local machine, or if you're comfort with doing it in this way, that's different use case. But best practice is to avoid wasting time here and there. We can try to containerize the process aspect. Whatever the AMI you create, or whatever the instance you create, always ensure to tag the resources so that if you want to filter it, if any AMI is being used, then if you automatically create a tag as part of the resource, then it will be easy to backtrack by running the API is filtering out based on the tag value and see any outdated AMI has been there in place or not, or like how much cost you could save or around that aspect. Also, always follow don't repeat yourself concept. If you are using Terraform, try to use that module, make it as a module so that you don't write the same code. Also, you try to introduce variables as much you could so that the code remains dynamic and you can repurpose it for some other use case and more on. So that's more I want to talk and share as part of today's session, like how you can create an infrastructure, in our case EC2, and how we can use Packer to create a golden image, and then how we can streamline the flow of creating the AMI using it in our flow, and how we can work on that part, right? So that's part of today's session. So I will make this code public post this session, and you can scan or you can visit GitHub ebdi infra streamlined repository to look at it. And if you have any specific questions, you can do connect with me over LinkedIn. Feel free to ask for any questions. Happy to assist or happy to answer if I'm aware. If not, I can still go and try to fetch the answer if I'm not aware about it. It's all about getting to know what we unknow. So any minor, major stuff, do ask it. If you're watching the stream live, I'll be around in the chat, so feel free to ask. Thank you. So thanks for staying till end of the session. Really appreciate your patience. If you have any feedback or anything, do approach me over LinkedIn. I'll be around. Thanks.
Thank you for a wonderful session, Kitivasan. We really understood how Packer and Terraform can seamlessly work together for the application deployment. Really good demos and good sharing your best practices as well. And I agree to don't repeat yourself, right? DRI is super important. So kudos for your session, and great job with the demos as well. So moving on, we will now take a short 5-minute break, just to stretch and grab some water, or just jot down some of your key takeaways, right? So let's be back in 5 minutes for another exciting session, which you don't want to miss. Welcome back, everyone. Hope you had 5 minutes of a good break and stretched and had some water and refreshed a bit. So before we move on to the next sessions, just a reminder that we'll be sharing all of these talks on YouTube in the coming weeks. So if you are just tuning it and you want to catch up later, you can also go through and just go through the talks that we'll be uploading to YouTube. So yeah, you can just go and check it out later on as well. So again, I'm excited about the reminder of the HashiTalks India. So we do have a few more interesting sessions coming up where we'll also be diving deeper into Terraform, Vault, and more, right? So it's been incredible learning from a few sessions that we had earlier, and I'm excited to learn a few more sessions about more sessions, right? So next, I'm thrilled to introduce our next speakers, Dr. Rahul Sharad Gaikwad and Varuneshwar Mathur. Dr. Rahul is a solution architect at AWS with an expertise in migrating and modernizing workloads in the AWS cloud. He is passionate about generative AI and DevOps. Dr. Rahul has an impressive background, holding multiple awards, including the Indian Achievers Award 2024 and Best PhD Thesis Award 2024. Alongside him is Varuneshwar Mathur. Varuneshwar is a solution architect at AWS, specializing in helping financial services industry clients optimizing their cloud operations and driving digital transformation. Over to you, Rahul and Varuneshwar.
Hello everyone, welcome to HashiTalks India, and thanks for joining this session today. Let me start with a scenario. Imagine you are sitting in the flight and your captain announces, "Ladies and gentlemen, welcome aboard. We are excited to try out our new single engine design. We have removed all the backups from the system to make the plane lighter and more fuel efficient. Enjoy your flight." How do you feel about that? Will you enjoy your journey? Right? I'm guessing most of us will scrambling for the exist. Now let's shift our focus to the digital realm. In the world of cloud computing and modern software architecture, we are dealing with a more complex system. Yet, surprisingly, many organizations are building their infrastructure without considering the redundancy and resiliency we are expecting in the aviation. Considering the same context, today we are going to talk about how to enhance your architecture, resiliency, and deploy your infrastructure with Amazon Q and Terraform. Before we deep dive, let me quickly introduce myself. I am Dr. Rahul Gaikwad. I am a solutions architect at AWS. My role involves guiding customers, especially in Indian financial services, they embark their cloud adoption journey. I am joining the session from the city of Pune, also known as the Oxford of the East, and I am also HashiCorp ambassador from the Asia Pacific region. At work, I like to travel, meet with the new people, and try out the new dishes. Today with me, I have my friend Varun. He will join us later to talk about architecture and a demo. With that, let's go through today's agenda. Here is what I will cover today. I will start with the introduction of the topic, and then we'll talk about the customer challenges, what are the issues, what are the pain points they are facing while developing their application and deploying their infrastructure. Then we'll talk about the resilience lifecycle, resiliency. Then I will talk about the approaches, how we solve these customer challenges by following the generative AI capability with Amazon Q Developer. And then Varuneshwar will join us to explain about the target architecture. He will also demonstrate how it helps us to build that infrastructure with the help of Amazon Q Developer. Then we'll conclude our session with the summary and what are the lessons we learned from this customer engagement. With that, let's get started. As our Amazon CTO rightly says, everything fails all the time. One of the tenets of good application design is to design for failure, right? Resilient application provide continuous service despite of disruptions. It can be a natural disaster, it can be a human errors, or it can be a hardware failure.
Now let's talk about some types of failures which you can use as a framework to build your resiliency threat modeling. And you can brainstorm on these categories to identify what kind of mitigations you can perform. And do you have a right observability in place to detect these failures? First is the deployment and configuration. What happens when you have a failed deployment? Maybe it might be in application or in infrastructure. Do you have a mechanism to detect it? And do we have any CI/CD pipeline mechanism to automatically roll back? The next is physical infrastructure. There can be a failure in your host or maybe an impairment in your single AZ. So do you have a mechanism to recover from that failure? Next is data availability. It can be a data corruption or missing any data or application state. What happens if your database gets corrupted? Do you have a mechanism to recover from that failure? Next is hard dependencies. In your application, there might be chances your application and databases might be depend upon third-party tools or different services, right? So do you have a mechanism to recover from that failures? Last one is unusual scenarios that can be possible if there is any natural disasters, for example, internet failure or natural disaster or like earthquake. Is your application able to recover from that kind of failures? Let's switch the gear. What is resilience? Resiliency is the ability of workload to recover from infrastructure or service disruption. Your application or your infrastructure should be able to recover from any kind of disruption. Like security, resiliency is a shared responsibility between AWS and customer. AWS is responsible for resilience of the cloud, and customer is responsible for resiliency in the cloud. When we talk about AWS, AWS is responsible for maintaining the resiliency for hardware services like compute, storage, databases, and their underlying infrastructure. It also responsible for global infrastructure, regions, availability zone, and edge locations. Whereas in customer has to take care of their infrastructure, continuous testing of their critical infrastructure, workload architecture, databases, and application from the resiliency perspective. They also need to think from the networking, quotas, and constraint perspective when they design their application and the infrastructure. That's how you have to maintain the resiliency in the cloud. Let's move on and talk about the customer challenges. In my previous engagement, I was working on one of a banking customer, and I have seen customer was struggling with lot of challenges. So in that customer engagement, I was a part of a solutions architect team where we were designing and reviewing their infrastructure and application. And most of the time we were building this failure mode effect analysis FMEA and calculating the risk priority number manually. Let me give one example how we used to calculate. We used to define the components, then failure mode, and what are the potential effect of that failure, and based on that we used to determine the security, occurrence, and the detection, and then we used to calculate the RPN. In this example, I have given a few examples, right? Web tier EC2 instance, if it get a failure, you can see there might be chances of service unavailability or maybe a reduced capacity, right? After defining the FMEA and calculating RPN, we were struggling on building and testing the resiliency and reliability of our application and infrastructure. And third-party services and tools we are not able to provide the resiliency testing mechanism for OLS and containerized application. So in that case, we had to define the customized scripts to do that resiliency testing. And after completing all this development, while deploying, we were facing a lot of challenges, and we were spending our time on troubleshooting and putting the observability around the infrastructure and application. So let's switch the gear and talk about the resilience life cycle, where we are spending a lot of time in a different type of stages in the resilience life cycle. As you can see, first is setting the objective for resiliency. So where we talk about business impact analysis, defining the RPO, RTO and SLOs, where we are spending time and we are doing all this manually. So next is the designing and implementing. You can see, as I mentioned earlier, we used to determine the FMEAs, calculating the RPNs, write the code. All this happens in this phase. So next is evaluate and test, where we will actually prepare the test cases, we will evaluate our outcomes, and based on that we will decide whether we want to go for the production or not. And after that we deploy that applications in the production, and then we identify if there is any resiliency issues or any performance related issues, and based on that we define the SOPs, we create an analysis, and we again provide that feedback, and then we work on that recommendations from that learning. Now let's discuss about different approaches which we followed to solve all these customer challenges. We use Amazon Q Developer to leverage generative AI capabilities to prepare FMEA, calculate PIN numbers instead of manual methods. We take the recommendations to build the resilient infrastructure and application from Amazon Q Developer. We also asked Amazon Q Developer to write a code for us to build the resilient infrastructure and the application. Also, we take the help of Amazon Q Developer to build the custom scripts for the resiliency testing of serverless and containerized application. Then we also take the help of Amazon Q Developer to build the best practices around the observability. And also Amazon Q Developer helped us to do the troubleshooting while we were deploying the infrastructure and application on our AWS cloud. And based on my personal experience, I have observed that earlier we used to spend almost 11 days for sample architecture blueprint release to the different stakeholders. It was earlier taking 11 days. With the help of Amazon Q Developer and manual efforts for the review, we have reduced that time from 11 days to 11 hours. With that, I will hand over to my friend Varuneshwar for the demonstration and the architecture. Yeah, thank you everyone. Varuneshwar, over to you. Thank you.
Thank you, Rahul. That was quite an insight, and I'm sure our audience today will be very much interested in knowing how we transform the release cycles for the architecture blueprints. Hello everyone, welcome to HashiTalks India. I hope you're having a good time. My name is Varuneshwar and I'm a solutions architect at Amazon Web Services. I'm joining you all from the Millennium City of India, Gurugram. Today, I'll be demonstrating the magic that HashiCorp Terraform and Amazon Q together create by implementing resilience in our existing architectures. So on the screen here, you see an AWS architecture. You have an AWS cloud depiction, and then we have a virtual private cloud with an AWS and a single availability zone that has been defined for this region. What we see over here is an Amazon Elastic Container Service that's been set up in a single availability zone. It is having an EC2 instance underneath it. Next, we see Amazon's RDS, that's Relational Database Service, that's running a single master node in an availability zone with no replica or reader instance created. We also don't see any backups being configured for these AWS services, and there are no alerts or monitoring that have been configured. So these points highlight the critical areas where these architectures fall short of any kind of resiliency or reliability. Now, in reference to the current architecture that we just saw, let's now use Amazon Q Developer to help us execute a failure mode and effects analysis. We will also check the RPN for the same. Here on the screen, you can see a Visual Studio IDE with Amazon Chat, Q chat interface open. I'm providing a prompt to Amazon Q to help me assess the FMEA analysis. I have provided the details of my architecture, such as running ECS with EC2 in a single AZ, RDS in one AZ, no backups or CloudWatch monitoring. Based on analysis, it has actually identified the services. So I'm single AZ, ECS1, EC2, giving me the score for severity architecture detection. It has identified that the RDS is without multi-AZ, giving me an effect of a database and giving me a score of it as well. It checks that there is no RDS configured and given me a total RPN score of 720. It's giving me recommendations based on the RPN score, and such as mentioning the CloudWatch monitoring, set up dashboards. Similarly for RDS backup, what can be done to improve the RPN score, and also for the single AZ infrastructure, it's giving me the recommendation. Apart from this, if you see, it has also given me additional recommendation, such as building regular disaster recovery or creating runbooks for common failure scenarios. So in continuation to the output that we got from Amazon Q Developer on the FMEA and RPN analysis for the previous architecture, I've captured the output in a tabular format here for an ease of understanding. So if you see all the resources that we had mentioned in the architecture, the ECS cluster, RDS instance, backups and monitorings have been categorized over here, with each of them having their respective reason for failure modes, what the effect would be, and then giving you a score for each of the metrics of severity, occurrence, and detection, and then finally giving us the RPN score. For this particular architecture, the classification became as high risk, and the overall score of all the resources came up to be 720. In the subsequent slides, I'll be showing you how we will be building in resiliency and improving this RPN score for a given architecture. So moving further, let me quickly show you how Amazon Q can help us provide recommendations on improving this particular architecture. Again, on the screen, you can see my Visual Studio where I'm continuing my conversation in the Amazon Q chat interface. I'm trying to fetch resiliency improvements and recommendations. I have put in the normal prompt of recommending the RPN score for this above mentioned architecture. Please note that I have not provided the component details again in the second prompt, and Amazon Q is automatically picking up the reference and setting the context and putting in all the RPN scores that it had provided us earlier. So for CloudWatch monitoring, it had given us a score of 336. Now it has given us a set of recommendations and recommended to improve the score to 42. A recommendation includes creating of alarms, setting up of logging for ECS, and SNS for notification. For RDS backup, we had an RPN score of 240, and it has picked up those details, and now based on the scenario, it is giving us recommendation to enable RDS snapshots, enable point-in-time recovery, set up cross-region backups for this database. ECS infrastructure in a single AZ has also been identified correctly. Picked up the RPN score of 72 earlier, giving us certain recommendations of implementing load balancers using AZ auto-scaling groups and the task placements for it. It has also gone a step ahead and given us a YAML configuration for ECS auto-scaling group as well. The RDS system, the database that we had in our previous architecture, was also in a single availability zone, and the recommendation here is to enable multi-AZ for those instances and implementing automatic failovers along with RDS proxy for connection management. Amazon Q has gone further and given us a few more recommendations around high availability, such as enabling, instead of 2, moving on to 3 availability zones, and also enabling cross-region replicas and recovery procedure for a TR setup. It is also providing us recommendation on security and performance. The RPN score comparison has been represented in a tabular format, and it is giving us the previous and the after RPN score for each of those components. It is also giving us an implementation priority order based on which component had the highest RPN score and which ones are the quickest to implement. So that gives us an advantage of how our teams can work on areas that quickly improve the resiliency of the architecture. It has covered that, also given us certain YAML or snippets of code to improve that profile. In the end, it also gives you a summary of, based on the total RPN score, from 720 to 94, it has actually represented an 87% reduction in the overall risk, and also suggests that regular testing and continuous monitoring of this implementation would improve the resiliency of the overall system. So here I have translated the improvement recommendations from the previous FMEA and RP analysis into my target architecture. Here you can see the ECS cluster is now provisioned using Fargate. Fargate is basically AWS's compute serverless offering, which provides extended resiliency by deploying computes on multiple availability zones without any need of specific management. We also have RDS database that has been set up in a multi-AZ setup, and it holds a read replica or a failover instance. We now also have AWS backup service that has been set up to manage backup life cycles for the given AWS resources. Challenges of observability are also being mitigated by implementing CloudWatch. All the alerts, critical metrics, dashboards, and delivery of those alerts will be managed by CloudWatch and SNS. Post this, we'll see how we can build a Terraform script to provision the infrastructure. Now I'll show you how Amazon Q can also help in generating code that is a compilable code as well. So here on the screen, we again see an Amazon Q chat interface, and I'm using /dev, which is one of the multiple modalities under which Amazon Q operates. We saw the chat interface previously where it was giving recommendations and doing executions and responses. /dev is specifically used when you want to use Amazon Q to generate code for a particular framework or a package that we are currently working on or want to work on in our IDEs. In this case, I am requesting /dev to generate a Terraform code which specifically follows a modular structure for the AWS architecture resources that we received as recommendation in the previous FEMA analysis. So I'm mentioning the ECS cluster, RDS, and backup along with CloudWatch services to be generated. So once this prompt is submitted, it tries to upload code. If there's anything open in your IDE, it gathers context, and then it is giving me all the summary that will be capturing and generating the code on. The VPCs, RDS backups, ECS Fargates will also be used. If I specifically see that it has also mentioned that there has been a change in the Terraform library and the code from provider, where the VPC attribute has been deprecated and Swift domain will be used. So these are kind of add-ons and benefits that we see with Amazon Q while you're working with code generation, because it keeps track of any new features or functionality that the latest versions of a framework or a package is now providing. So it has identified that it will be generating some 18 files for this Terraform code. I'll quickly move forward. And here it has given me a list of files that it will be generating, and it is requesting me to accept these changes. So as an engineer, you can actually go through these code files, and if you're okay with the code and you do not want another execution, you just apply the changes, and we would see these files coming up in our Project Explorer. Let's look at one of the configuration for backup. So Amazon Q also gives you details on the security exception that your code actually starts showing. So it has given a CV 3WE for an unencrypted backup vault and requests us to add encryption also while we are creating this backup vault. Similarly, if you go to ECS, we make sure that Fargate has been selected, and Fargate as a deployment type, that is the monitoring where all the alerts and configurations are being mentioned. We also see RDS, where again we saw some security vulnerabilities for encryption that needs to be implemented. We specifically mentioned that we wanted to use RDS in a multi-AZ setup, which is marked as true over here in the Terraform script. Slightly moving further, we jump onto VPCs to see all the variables are being connected or not. Another thing that I want to bring into notice was the best practices of Terraform snippet are also being followed over here. For instance, we see DB password as one of the variables, and its sensitivities have already been marked as true. So these are small things that probably a developer can miss, but Amazon Q has provided these Terraform insights while writing the code in the best practice, after following the best practices. Right then, after doing all these checks, we should move forward and try running this code. Let's open the terminal, see our code in action. So here I'm initializing the Terraform, and as you can see, I'm already getting some recommendations when I type in Terraform. This is another feature of Amazon Q where it works with your CLI and terminals and gives you prompts to complete the commands. So initialization has completed, and we should see, so yes, we have already completed initialization. I'll just quickly do a plan for this script, add values for this. I see 34 modules that were added as per plan. Quickly doing a check of all the services and checking the variables. And output variables. Let me run the plan and see it started run. So this is so amazing, right? So you already got a code compiled, it is ready to be compiled with minimal changes, right? So it totally depends on how what kind of a prompt you're giving QDev, how clear it is in its ask, and it generates a fully working code for you and following the best practices for that particular platform or framework. So yeah, so it's now creating all the VPCs, all the components, services that we have requested for. Okay, so we got an error around the version. So I had requested for a version 16.4, which incorrectly got processed, and it's added version 14.6. Pretty sure 14.6 is a valid version for them. Probably it's not available as a version to be deployed. No worries, we'll quickly change the values here, and that's the fun of writing code live and then showing it to our audiences. So yeah, so I'm quickly going and changing the version to 16.4, and let's give it a run again. So I'm again approving the change. Let's see how that moves. All good there. Okay, so we got one more exception there. This time it is on the database's username. So RDS does not allow us to use admin as a username because that's a restricted word in AWS. So quickly moving forward, I'll fix that as well. I'll name the database. I'll approve the plan. Moving further, making it to HashiTalk demo and applying the changes. So it's creating the resources for us again. Almost done with the changes. I'll move forward. I guess if you all know how, depending on the resources, this would take some time to create. I'll just wait for the voila moment once the resources are created. So yeah, so apply created. We have the output variables for the script now ready for us to validate. I'll also take you to the AWS screen shortly where we can together see the resources that have been created. Here we are on the AWS screen. Let's quickly pop into RDS. That's double checking the name of the cluster. We have a production Postgres system. The essential thing that we want to check here was the multi-AZ configuration. Perfect. So this is what we wanted for the RDS Postgres to be set up as. Let's move forward and go to ECS this time. Again, we have a production cluster created. We see that container insights have also been enabled, and I just want to quickly double check on the infrastructure, and that's right. So we have Fargate and Fargate Spot as capacity providers over here. Moving ahead, We'll go to AWS backup. We wanted to have a separate vault for AWS backup that has been created. I requested for a daily backup. That also is what we can see. Quickly skim through the VPCs that have been created. Perfect. I used two AZs and we are good to go. Lastly, let's check the CloudWatch. So we have DS, all the required metrics captured over there. And we have the alerts for them also created. This is good, gives us good observability. Now, quickly moving on, we would want FME execution of this target architecture also. So I'm putting in the request to run the FMEA on this target architecture, giving all the component details over here. And we have the FME analysis for the latest updated architecture as well. It has gone through all the components, the failures, and giving us the updated RP and scope against each of these architecture. I have captured these and will be showing it to you shortly in the next slide. So here I'm summarizing the FME analysis and RPN on the updated target architecture, which had resiliency built in. The resources are captured over here with the RPN score against each of those components. As you can see, we saw an RPN improvement from 720 to 125 with this updated architecture. This number could have further changed and reduced if you would have implemented the recommendations such as disaster recovery, and that would have impacted in further reduction of the score. I hope this session was useful and we were able to provide you meaningful insights. Thank you so much, Rahul. And thank you, HashiTalks, and the lovely audience for all your attention. I would like to end by saying, let us all build stronger, more reliable systems together. Thank you so much.
Thank you to Dr. Rahul Gaikwad and Varuneshwar Mathur for an insightful session on improving architecture resiliency with Amazon Q and Terraform. Your practical examples and strategies on deploying infrastructure were very helpful, and I personally learned a lot from this insightful session. We gained really valuable knowledge on how we can improve our own cloud architectures. So thank you again for your time and expertise. I have another announcement to make. If you are not aware, HashiCorp also runs an HashiCorp user group. So join an HashiCorp user group around you. The HashiCorp user group program spans around the world in 63 countries with over 50,000 HashiCorp users across 180 chapters. There are 19 HashiCorp user group chapters in India, and we want you to join. Visit hashi.co/hugs to find a chapter near you or learn how to start your own. So up next, we have Kamalika Majumdar. Kamalika is an expert in driving continuous delivery for customers across various domains like banking, finance, insurance, e-commerce, and retail. In her session, Kamalika will discuss compliance as code, focusing on how to design and implement this approach for third-party information security audits with real-world examples of ISO and SOC 2 compliance using Terraform. Take it away, Kamalika. Kamalika, you are on mute. If you could just unmute.
Oh, I'm sorry. Let me start again. So this session is going to be about how to navigate complex security standards and frameworks through compliance as code to streamline implementation of security policies in your infrastructure. First up, what are compliances? Many of us may have a misconception that compliances are actually policies or rules or configurations that are given by government, and we have to implement it so that we can get certified. Well, that is not exactly correct. Compliances are actually frameworks which are there to guide organizations on how to secure their assets, manage various risks surrounding their assets, and more importantly, how to take necessary steps to govern their information security. These are basically guidelines that will help organization to protect their intellectual property. For example, a compliance can tell you that in order to protect your information, you need to make sure that your user endpoint devices are secure. But and that can be done through various measures. But a compliance will never tell you what kind of malware protection or antivirus or security policies you need to configure in that. So it is very important to understand what these compliances are saying to drive these information security, and more importantly, how to translate them into code so that we can implement it for a longer time. This session will focus on examples driven from two major industries which are connected to infrastructure security or information security. One of them is the financial services industry, especially like banks, insurance companies, and fintech companies, basically companies which who deal with people's money. These set of industries sometimes may need more than one compliance. They may need ISO 27001 and or some other data security, along with other data security compliances such as the OJK of the Indonesian Financial Auditor, or if you consider India, there is a new data security policies which has been introduced a year back to ensure that the data which they are storing of their customers is secure, and they need to meet these stringent measures. And sometimes in this set of organizations, which are the financial services, compliance is very important. To otherwise, non-compliance can actually cause hefty fines, and sometimes may even lead to cancellation of their licenses of operation. So another set of companies where I will, which will also apply to these set of example, is software development companies, especially those offering SaaS or cloud-based services. These set of companies sometimes may or may not mandatorily need to certify to a compliance. However, they often seek compliance or certification or compliance implementation rather, such as ISO 27001, PCI, or SOC 2 for the services company, because that helps them ensure or build a framework around information security and manage various risks that might be associated with their software or applications or services that they're giving. These compliance guidance can ensure practices to align with industry standards. So what is the baseline for any compliance? Widely, these compliances are based on what kind of data is being stored or the type of information that an organization is storing. It is widely categorized into three groups. One is PCI, or payment card industry data, basically your credit card, debit card data. Mostly you will see e-commerce companies, retail companies, or even some financial services companies may have to adhere to this. If they are storing payment card information of their users, they need to adhere or secure that information. The other set of group is PII, or personally identifiable information. If an organization is storing information of their customers' personal information, such as name, address proof, government IDs, email, sometimes even email IDs, personal email IDs, these might be considered as personal information or PII data. If they are storing that kind of data within their application or within their infrastructure, they have to protect it, because at the end of the day, it's someone else's data that you're storing, so you cannot just misuse or let that data to be compromised. The third set of data or information based baseline for compliance is PHI, or health information, protected health information. These are basically, you will find companies who are building softwares or services or providing services related to health, insurance, basically insurance companies, health insurance companies, medical companies, who can be storing critical health information of individuals So that also will have to adhere to certain rules and regulation or compliances. Examples you can see in the PCI group. The one most common and widely accepted compliance is PCI DSS. In the PII group, there is actually a wide spread level of compliances, and it also depends on various regions and countries. But like ISO 27001, SOC 2 also deal with the PII kind of data. Additionally, PII data may also be governed by country-specific rules and regulation. As I mentioned earlier, in Southeast Asia, like in Indonesia, there is one which has to adhere to OJK or their financial auditor. In India, we have data protection laws. And another example of in the PHI or protected health information is HIPAA, GPDR, and things like that. So these, based on the categories of information that an organization is storing in its infrastructure, they need to adhere to certain compliances or standards of how they should protect that information. What are the challenges with these compliances? The biggest challenge that I personally have faced and have seen over the years in implementing these compliances is interpretation of their controls. Most of these compliances are focused on providing guidelines or frameworks to cover a widespread of number of industries. Although in this session, I'm focusing mostly on financial services and technological firms, but these are not limited to only these set of industries. These compliances also cover other industries that are there. That's why you will see a lot of these controls or directions that they give are very wide. It covers a wide range of categories, and to interpret them into configuration of what has to be implemented in our infrastructure is a big challenge. And the second most important challenge that I see and have faced is their evolving standards. In 2024, PCI DSS version 3.2, which was the earlier version, had expired in April, and they had introduced a new version, which is version 4.0. And that new version had 50 new benchmarks. Similarly, ISO 27001 released a new version in 2022. And next year, in October, by end of October, the existing ISO 27001, which is the 2013 version, is expiring, and any organization which has an existing certification of the older version has to upgrade to the newer version. Otherwise, they will not be considered as compliant to ISO. And these new versions, for example, in ISO, they had done a lot of categorization, reduction of their controls, and reframing of grouping of controls. So a lot of changes happen as our technologies are evolving, and you will see a lot more changes in these compliances in future, because with AI and other evolving technologies coming into the market, the more emphasis will be put on data protection and information security. So these standards will keep evolving, and this is a challenge, because if you cannot translate them and implement them effectively in your organization, then they will be just like paper work that will be remaining. So how do these challenges impact real life implementation? These are 4 examples. These are real life examples that from my previous projects. For example, when I was doing ISO 27001, actually when I was implementing or building an infrastructure for a fintech or a financial services application, I didn't know that it had to be, I had to build it with respect to ISO 27001. Instead, what I was told was that you need to build an infrastructure which you need to conduct a DR drill to comply with ISO 27001. Now, when you go ahead and look out for the ISO rulebook, you don't see an exact control which maps disaster recovery drill for ISO 27001 or any kind of direction or control which says that you have to do disaster recovery to meet this compliance. What it does mention, and I'm going to show it in one of the examples in a couple of slides later, is that what it mentioned is that you need to maintain availability and integrity of your systems so that you adhere to your business continuity plan and your systems are always available in line with your agreed terms. So that is the language that is there in the ISO compliance. But when you come to implementation as an infrastructure developer, all you know is that you need to conduct a DRDL, but you don't really know where the link is. So you see the gap that exists over there. The second example, I also see that SOC2. I was building SOC2 based infrastructure for an organization, and they had a questionnaire which was where there was a question which said, are your data center SOC2 compliant? Now, if you look at SOC2, you would not see specific direction as to say, what does it mean? What does it mean to have a data center or data centers to be SOC2 or ISO 27000 compliant? When you actually translate that with the description that how much of an availability you need, it means that your data center must have a disaster recovery compliance, meaning they should not exist within 60 kilometers. Basically, they should not exist within the same disaster recovery zone. So these kind of translations will be missing, and these kind of translation will only come in when you start implementing these compliances. Likewise, for OJK, which is a financial services authority of Indonesia, they, according to that, you will only hear you need to have the data stored within the country. It cannot leave the country. That's all you will hear. But you will not be able to map what exactly it gives OJK. So that means what they actually need is that they need data localization and data residency within the country. And that translates to storing your data within either cloud or data centers, which is located within the country. So these are the challenges that we face in implementing these compliances on the ground, and because of which many organizations hesitate to implement them from day one, because they feel it is complicated or it is time consuming, because they lack the understanding of what it translates to when it comes to implementing these on the ground. Now, how we can solve these through compliance as code? First up, compliance as code is basically you convert these controls, regulation, what comes from the security standards, interpret them in line with your organization, and automate them in terms of infra components, so that you don't reinvent this wheel every year, because these compliances or security regulation also requires you to conduct at least one annual audit, and every 3 years you need to recertify. So you will see, if you have compliance as code, then you may not need to reinvent the wheel every year. The first or one-time investment that you do for a couple of months in the beginning, you may not need to do the same thing next year. Next year, it might as well be just running or capturing the evidence that are collected from your implementation and submitting them and just recertify them. And it can happen within a matter of weeks. Another, application compatibility will increase, because when you start with compliance as code for day one, from your development to production environment, you know that your infrastructure is compliant, and it comes right from day one in the form of code, and you don't have to wait until the very day of audit and scrape around what kind of evidence I can show. Portability, it also gives you portability across cloud platform, and this is not very much spoken about. If you have a standard framework under which you're designing your infrastructure and building code for it, it can actually help you in future migration. For example, when I was doing a migration from one cloud to another, it became a lot more easier for us to migrate, because our logical infrastructure design was the same. And we knew that this is the design that is compliant with the security standard. So portability increases. Continuous integration and delivery of security as code. Your security becomes a first-class member instead of an additional configuration that you will have to impose on top of all your systems. Testing these policies on infrastructure becomes easy, and these kind of testing also increases your reliability and availability. And as it is said, security is not just about privacy and confidentiality. Security is also about your availability and your integrity. Another advantage of compliance as code is while you are doing risk assessment and risk treatment. Risk assessment is one of the first critical step in ISO 27001 implementation. In fact, it's the only step, or maybe the only document, which the auditor will actually see. The rest all documents auditor will not go and verify. This document the auditor will actually check and see whether you have identified the risk and what kind of measures have you implemented, and have you implemented the ISO controls effectively. For example, and this can vary from different companies to companies. For example, for a small consulting company, losing 4 hours of data might not be that much of a big deal, and it can be an acceptable risk. But for a large company, maybe telecom company or a bank or a financial service, losing that data means it is actually won't be able to charge the customers, or they will be charged with losing customer data, right? So these kind of incidents, these kind of risk management or conducting a risk assessment also becomes easier when you have compliance as code, because then you can straight away look into your code, your results, and you can see how much have you implemented. And more importantly, let's say you are a product company and you are launching a product line every year. Now, if you're doing that, you know that newer environments that are coming in your product line, they have to just implement it, and it is easier for you to implement the same code and build the same infrastructure which you have designed initially. So it's, if you build it one time, then you can multiply or implement it in as many environments as possible. Likewise, in cloud migrations, we have seen people migrate to and fro cloud platforms, or from cloud to an on-premise platform, and likewise. Now, if you have compliance as code, all you need to do is modify it according to the cloud provider, but the basic design and configuration remains same. For example, if compliance as code, if the compliance or let's say the security standard tells you to have segregated networks, you can have segregated networks across any cloud platform. So that becomes a standard that you may ensure in all your cloud platforms. Even if you're migrating, let's say, from AWS to GCP, you know for sure that this one feature is definitely necessary for us, and you don't have to scrape around and do another new design for another cloud provider. Disaster recovery drills becomes extremely easy when you are doing compliance as code, because then everything you can run from a pipeline, and you can record them, and it's just a matter of taking those logs in your CI/CD pipeline and then showing them to your auditor, saying this is our disaster recovery drill. And you can also execute it yourself. You don't have to lose a lot of time to do these to prepare for these drills. You can just focus on the drills. So how to build compliance as code? Let's look at some of the examples and how you can create in this particular couple of slides. I have picked up 4 specific controls from ISO 27001 2022, the newer version, and I'm going to show how I have built some of these compliance as code using Terraform. And Terraform will be our basic compliance as code platform. GitLab will be our deployment engine, which I have used, and AWS is what I'm focusing on as our infrastructure provider. This can as well apply for GCP or Azure or other platform. Because you have Terraform, you can have similar setup for AWS or GCP likewise. So first, one kind of information I wanted to share is that the new ISO 27001 has 93 controls. Previous one had 114 controls. So what they did in this one is actually they categorized them into, and they did a lot of reorganization. So they have categorized them into 4 groups: organizational, technological, physical, and people. In this session, I'm focusing on 4 controls, specifically from the technological controls. And this part of control makes more sense for infrastructure developers or while building the infrastructure, because these are very specific to how your infrastructure must be built, etc. The other type of controls is a mix of technical as well as documentation related and people related and policy related. And also another information is that this the present version of the 2013 version is expiring on October 31st, 2025. So anyone who has an existing version, they need to recertify to the newer version, otherwise they will have an expired certificate. So it is all the more important to start focusing on compliances code right away, because we have less than 1 year left. And if we can invest 1 or 2 months, or I don't think so we need 1 or 2 months, 1 month, a couple of weeks in it and build it, it will help us in the longer run. Segregation, first up, this is a control 8.22 segregation of network. This control of ISO 27001 says that the groups of information services, users, and information systems shall be segregated in the organization's networks. So basically, it is kind of in line with the previous version. Also, they had a similar control which called segregation in networks. And when you implement it in AWS, what it can have is, what it can translate it to AWS is a set of configuration that you can apply to various AWS services. But primarily, I have highlighted some of them, which are mostly common across all sides. For example, your instances must be in VPCs, your S3 bucket must have public write prohibited, and likewise, you have VPCs, security groups should be open to only authorized ports. EKS endpoints should not have public access. VPC internet gateway should be VPC. And so basically, you need to have a VPC or private network, and it should be segregated. So how did I build this? I created, I'm going to showcase you three of my modules. Although in every modules, these features can be implemented in other resources also, like EMR and RDS, etc. But I'm showcasing you the base module. So when you build an infrastructure, the first module or first thing that you create is, especially on cloud, is your network. And that's why it's very important that you focus on building the network in a proper security. So this is my network module. And you can see that I've already segregated it into 3-tier network, which is private, public, and protected. Private means no outgoing internet access, and incoming access is only restricted to internal application specific, whitelisted to specific, and everything else is denied. Protected will have minimal access from specific other applications and may have internet access. And public means the subnet, which can have anybody from the public internet incoming access. And these are basically for your load balancers or public facing endpoints, for your web endpoints, and etc. like that. So and the other which was specified, that your default security group must not allow anybody any unauthorized traffic. So here is one example how you can do it through your default security group. And recently, 2 days back, AWS had actually released a feature which they are blocking default public access in default in any VPC that you create. So I think that will be good, because then we will have less of a configuration that we are doing it with the previous set of VPCs, where there would be a default security group which opens up any access. But I think if we implement that, then we need not have to specifically go and mention it. Likewise, in S3, like they said, block public access. So you can block all public ACLs, all public policies with the S3 bucket policies. And the other configuration that they mentioned is EKS, having no public access. So you can create your EKS, and actually it's recommended to create EKS within VPCs with specific security group. Private endpoint access and endpoint public access also is, whether you enable or disable it, you can make it false and things like that. So another example, another control 8.20, which is named as network security of ISO 27001. It says that network and network devices shall be secured, managed, and controlled to protect information in systems and applications. And what does it translate to in terms of our AWS infrastructure? It can translate to things like similar things. Mostly instances are in the VPCs, S3 bucket, and then there are specific things like ACL. If you have a certificate expiration check, there has to be an ACS expiration check, and EMR should not have any public access. RDS instance public check should be public access should be checked. VPC default security group must be closed, which I have already shown. There is another one, interesting one, which is like security hub is enabled. Now, security hub is AWS's one of the AWS service, which is a security posture management. So security hub actually checks through all these frameworks. They have predefined rules to check whether your PCI DSS compliant, how much of a scoring you have across PCI DSS or NIST and things like that. So security hub must be enabled, and that also you can do using your Terraform modules. For example, let me go to my security hub. So here, like here you have the security hub must be enabled across your organization. You can have standard certification. And when you have these rules, what you can do is, what I usually do is I create these modules independently, and then I can deploy them through my provisioners. For example, I create my network, and my network will just pull my network module, and it will just have that. And likewise, for security, in security hub, you can enable it for various standards which will check your policies whether you are complying or not. For example, security hub standard frameworks currently have PCI DSS version 4. It still does not have 2000 ISO 2022. It has HIPAA, it has NIST SOC2, but you can also create your enable standards like this. So audit manager, security hub, these are some of the resources in AWS, and there are equivalent services in GCP as well, which you can configure using Terraform modules. And make sure, the important part is making sure these are part of your base setup or admin setup, as I would like to call it, before you even create your development or production or non-production environment. Create your admin setup which has your network, your logging, your monitoring, your security enabled, and then you start creating your environment. Because once you have these centralized environments which adhere to security, and you start monitoring and creating your environment with the same base policies, then you don't have to think about what I have missed in my infrastructure. Likewise, there is a standard control which says prepare for redundancy in IT systems, which is actually translate to the availability information processing facility shall be implemented with redundancy sufficient to meet available requirement, which means this is the one which is closely related to your disaster recovery drills that you have to perform for a ISO and SOC2, right? And same wise, like network for VPC, you can have multi-AZ, which translate in terms of cloud, it translates to multi-AZ VPCs. So you can create multiple availability zones. For example, in here, you can see that you can have all 3 zones, all 2 zones, whichever your suits your are available. And even for EKS, you can have a multi-cluster EKS and things. I'm giving just example, but if you see, I created 3 modules, network, S3 and EKS, and in fact I am able to cover 3 of the major controls that are there in ISO 27001. Right now, imagine you don't have to create one control for one module for every control. It's just a matter of understanding them, translating them, and building them in terms of code. So once you have that, then you can run them via pipeline as code. The example is, let me show you. Here's an example of this is a GitLab pipeline as code. You can translate, have a similar one in GitHub or Jenkins or whichever is your choice of CI/CD platform. But you can have a specific stage here where once you run it, you will be able to see, is it running successfully? Is it running? Has it failed? And you can also add tests which can run effectively for these, so that if security pipeline fails or security stage rather fails, you will know that, oh, something has failed in security. So you don't have to wait until your audit cycle has come in to look for security in your organization. If security breaks today, it will just become normal part of your software development process. Like what you do for application bugs, you can do the same thing for security bugs. And you need not postpone it for until your annual audit or annual certification to implement it. You can implement it in your, you can spin up an environment, implement this security patch, leave it for a day or two, and then you can go ahead and implement it a week later once it matures. And once you have this kind of process, you can also gather results. So this is a snapshot from AWS Audit Manager for PCI DSS, and you see that it already starts capturing evidence based on what you have implemented in your infrastructure. So you can download these reports, and this becomes handy for you. Otherwise, you will have to run around, build documentation. This is one of the most challenging parts of compliances, is the documentation, building evidence and collecting evidence, and like this. So finally, the benefits is, of course, automated deployment, auditing of changes. You have audit, it will be easier, automated testing and configuration management, version control, evidence connection. So it's not just evidence collection in your Microsoft Word document or Google Doc or some kind of hard copy of papers. It's actually version control. So you know what state you were in last year and what you are in today. So you already have that recorded. Pre-audit preparation, as I said, and also post-audit review, because one of the biggest requirement for compliances is that it is a continuous process. You need to monitor and keep doing it, keep improvising it. So post-audit, you can monitor if you have failed some compliances, what was the gap that you did not implement. And you can do it internally. You did not go to an auditor outside. You can practice this internally and be prepared better for your audit certification. And these certifications are not very cheap. They are very costly. One day of an auditor costs a lot. So if you do internal audits using your compliances code, you know what state you are in. You will be more confident that you will not lose that audit money. And we have been hearing a lot of it recently, that how audit was failed and nobody know where that money gone. So you will be accountable for the money that you're spending for this audit, that you don't fail that audit, right? So that's all about compliances code. I hope you guys enjoyed and learned about compliances code. If you want to know how I'm building my compliances code for ISO 27000 or any other compliance that I showcase, visit my website, which is www.10factorinfra.com, or simply 10factorinfra.com. Or you can connect me on LinkedIn. You can scan the QR code, and this is my LinkedIn ID. And I hope to see you all in the future. Thank you so much.
So that was an amazing talk, I would say.
Yes, definitely. Compliance is kind of a right now the main requirement of every company. I mean, it's from the government side, it's from the regional obligations. You have to do it. So yeah, it is great to know about all these excellent ways to achieve that. Yeah.
Absolutely, Sandeep. I agree with you.
Correct. True. Well said. And I think Kamalika, your session was really good. I think I took a lot of important takeaways from this. Now I'll be handing over the MC to Dheeraj and Sandeep. Dheeraj and Sandeep both are HashiCorp ambassadors. So over to you guys. And thank you, HashiCorp, for extending the invite to me and giving this opportunity for me to be an MC for the event. Thank you.
So guys, we are really happy. Thank you, Adit, for handing it over to us. And hello guys, how are you? So it's good to be here and as an MC host for the upcoming sessions. So the next upcoming session is Sandeep.
Yeah, definitely. So next is having the cross cloud network automation with Waypoint and Terraform by Paras Mamken. So it's going to be another exciting session. So let's see.
So guys, without wasting much time, we will put our next speaker live. That is Paras. So Paras, can you hear us?
Hello all, and thank you for joining us today on the topic cross-cloud network automation with Waypoint and Terraform. With this topic in mind, I can assure you that we'll be talking about how the complex architecture around cross-cloud network or interaction of the applications between different cloud service providers can be simplified with the help of automation, specifically using Waypoint and Terraform in this case. We are presenting this topic as part of HashiTalk 2024 India chapter, and with that we will be taking you step by step of what are the challenges, how the challenges can be automated, what are the ways this deployment, the delivery pipelines can be justified, and then the major focus will emphasize on one architecture that will help you to visualize how the cross cloud networking usually works, or how it could look like in a very naive fashion. Myself, Paras, I work as a cloud engineer. My work mostly revolves around working with different cloud networking technologies, and how the different producers and consumer services in different cloud providers can interact with each other, or you can say an application which is running on one cloud can actually connect with the other services from different cloud and ensure that we have a very highly available or a robust architecture or the design that supports different loads, high performance, high reliability, and can serve the increase in traffic demands by the user, and can tone down their infrastructure if the demands do not require the high set of infrastructure to ease out the cost related aspects. To start with the challenge of managing multi-cloud is basically how do we manage the complex multi-cloud infrastructures. So we have different cloud service providers having their own set of services, products, and in order to ensure that we could use them at its best so that our services are highly available, they can scale easily, there has to be a seamless workflow across the way we are deploying the services, the way we are deploying uh, the infrastructure onto this cloud, and they are like very closely or smoothly interlinked with each other, so that the moment based on the increase or the requirement of demand, the corresponding infrastructure or setup can scale up and scale down. So that is something that we visualize we would like to have while we want to manage multi-cloud infrastructure. But the challenge comes with when we have to do all this manually. We have to overcome all the tedious task of managing the multi-cloud infrastructure sitting in different components in different regions, and as an individual, as a team, we don't have the bandwidth to manage everything by ourselves. So that's where the things gets little tricky and complicated. The solution for this is we can automate the cross-cloud automation with the help of Waypoint and Terraform. So with the Waypoint and Terraform, what we could do is we could actually simplify the setting up of the end-to-end infrastructure that we have with us, for which we require to serve the traffic, which we require to serve our business needs or the applications that we have, the way we would like it to be handled by our cloud infrastructure. So moving towards the automation will be the place or the process where we could overcome the manual overhead that we talked about in our previous slide. So with Waypoint, what we could actually do is, or even before Waypoint, let's talk about what the Terraform could help us to do. So Terraform, as most of us are aware of, is infrastructure as code. It helps us to write certain scripts in a way that the infrastructure, the instances, the resources that we want to deploy in cloud can be automated. So it's basically a set of reusable scripts, reusable we can basically recreate resources using the same set of scripts. We can have a bunch or a collection of scripts written, or you can say modules of Terraform written. We can use that for creating our dev environment resources. We can then tweak the configuration values or variables and recreate the same exact similar environment for our production environment. And similarly, we could further scale it for development environment, testing environment, and so on and so forth. Had it been manual, it would have taken a lot of effort for someone from the team, effort, time, money to bring this entire infrastructure all manually. And that's what we want to avoid. We don't want to have this being done manually. We want this to be done like with leveraging the automation, which will help us to recreate the same resources, the way they are interlinked, the way the flow works across these resources, the way they are actually connected with each other. For example, if you have a certain pattern in place where you want your network, then subnets, then certain firewall rules to be configured. Once these firewall rules are configured, only allowing certain set of traffic from the compute instances, or you can say virtual machines, to flow in. And while this works, we would like to replicate the same set of environment for maybe some other user, or let's say maybe some another environment. So in that case, Terraform actually helps you to identify, simplify the task of how it can actually complete end-to-end the end-to-end flow end-to-end flow of your infrastructure deployment, and emphasize a lot on automation and reusability aspect. So that's where Terraform is the go-to infrastructure as code that we've been talking about. Now think of Waypoint as an add-on to it. What Waypoint will help you to do is it helps you to simplify the deployment, or you can say, if in a layman terms, like it helps you to define some patterns, the workflow which developers can easily manage at scale. So this is where like your Waypoint comes into the picture. So you've got Terraform in place. So basically, to start a scratch, you have an infrastructure in mind that you would like to work on, or you would like to be created for your team or your company for certain use case. You use the Terraform to write this infrastructure, and then comes the Waypoint, which is a deployment tool that helps the developers standardize or simplify how the applications can be built, deployed, and released. So basically it complements the Terraform, so which focuses on infrastructure while provisioning by streamlining the application's lifecycle on top of the infrastructure. So Terraform sets up the infrastructure required for your application, like virtual machine, Kubernetes cluster, databases, networking resources. So this is where Terraform helps. And then comes the Waypoint, which helps for the application deployment. So after Terraform provisions the infrastructure, Waypoint steps in to handle the application deployment and release process. It provides a consistent workflow for building, deploying, and releasing the applications that all we are aware of. So the way they work together is Terraform ensures that your underlying infrastructure is ready. It can be consumed, for example, tying up or creating different services like Kubernetes serverless platform like Cloud Run, etc. While Waypoint ensures that the application is built and deployed onto that infrastructure seamlessly. So this is how they are, like they complement each other. So while one helps you to create your seamless infrastructure, the latter one helps you to standardize your app delivery pipelines. So this is where it helps you to like set up your end-to-end cloud infrastructure, specifically in case of cross-cloud networking. So this is the slide that we actually covered in the previous slide, where we talked about how Waypoint simplifies the path from development to production by offering us consistent workflow across multi-cloud environment, reducing the frictions, automating the providing us the faster delivery, and so on. Moving next, so we've also talked about what Terraform is, how the automation and scaling across cloud, if done using these tools, can benefit us in scaling our application at large, can help us to solve other real world challenges rather than the challenges which can easily be solved by these tools. And then the next aspect is if you want to achieve high availability for the cross cloud infrastructure. So the key thing that we want is we are looking for a resilient and a scalable applications. So like basically that's the crux of why we want a cross cloud connectivity. We want our applications to be highly available. We want them to be resilient. We want them to be able to manage different demands or any outages. We don't want there to be a single point of failure. We want the load to be balanced across different regions for high availability. Let's say if there is a traffic or there is a increase in traffic from certain direction or from certain specific regions, then it could be or it should be handled by the other regions. So around those lines, we want to achieve high availability, and that's why we are or the enterprises right now are looking towards cross cloud infrastructure. So with the while focusing on this, what we are basically trying to do is we are breaking the cloud silos. So let's say currently we have if we have couple of cloud providers which are being used by a company, the intent is not to have like cloud silos or the applications being deployed into the individual cloud providers with them not interacting with each other. What we want is that entire different cloud providers or the applications being deployed into them could actually interact with each other. For example, if I have a simple application which interacts with a database, serves the traffic, I would like it to be in a way the load to be balanced in a way where if thing goes down at a certain provider or at a certain cloud, they could easily be managed by another cloud or elsewhere, so that my customers do not feel the impact. They still continue to use the application. They can still continue to have the same great, or you can say a good user experience. They do not see the outages impacting their businesses or increase in demand slowing down or increasing the latency of the requests that they are making. So that's what we want basically to make sure should not exist. We want have a seamless experience, and for that we want the uh, the applications which are deployed in cloud working in silos should not exist. It should be one seamless flow working everything in together. In the next slide, basically I would talk you through what one such use diagram, architecture diagram could look like. The intent for that diagram is basically to showcase how a possible connection across multi-cloud can be made. This is not a reference diagram, or I would say not a customer or a production ready architecture, but what this could help you to is to ease out or to understand how these solutions can be used. So in this diagram, taking Google Cloud as a core point in this networking domain, we have like VPC being present inside a Google Cloud org at the US Central 1 region. Then we have cloud routers and a cloud VPN gateway. So what we are trying to say that a user from the left hand side can actually be accessing your resources in your Google Cloud from any of the source or the destination. Like we could have resource from any other major cloud provider. That's one. We could even have someone accessing it from their offices building, or even at their home or home offices, or maybe at their on-prem machines. So the way we could handle is, if someone is trying to access, like we could actually set up connectivity across different cloud in Google Cloud using cross cloud interconnect. So that's one where a physical connection is actually established between Google Cloud and the other cloud providers, and that helps us to ensure that there exists a connectivity which is very robust enough to support high traffic with a pretty good bandwidth. The second one that we have in place is called Cloud Interconnect, which then comes with further two offerings called Dedicated Interconnect and Partner Interconnect. So we'll not go into their intricacies, but The intent here is that the cloud interconnect helps you to establish connection between using co-location where you actually have a physical connection coming in from your on-prem devices, and then the the other side of the cable is connected towards the Google Cloud. It helps you to establish the connectivity across two different source and destinations, and then there is a seamless traffic that actually flows. So both the interconnects are actually recommended and good if you're looking for very low latency, high speed, and a pretty good bandwidth. The third one that we have talked about here is called Cloud VPN. So it uses the usual HAVPN concept, where if you want VPN to be established between two locations, you could actually use Cloud HAVPN to establish the connectivity across two different locations. So once you have got the connectivity established, definitely we are not saying that you should have all the connectivity against one single VPC or everything at one place altogether. It just a means to show that these are few options available for establishing the cross cloud connectivity or even the connectivity from your on-prem. But you could choose either one of it or a couple of them based on the workload, the availability you are looking for, and then establish the connectivity with your Google Cloud VPC. Once you have established the connection with your VPC, what we are eventually trying to say that any services which is connected with this VPC could be reachable to your source, provided you have the cloud routes, the firewall rules, the appropriate permissions sorted. So let's say if a user from your on-prem wants to make some CRUD operations to your AlloyDB instance, or maybe for, let's say, Cloud SQL instance. So what you could do is you would actually opt for having either a cloud interconnect in between Office building and the Google Cloud, or you could even use HAVPN to establish connectivity between your on-prem location and your Google Cloud location. So once that connectivity is established, your user could actually be able to reach out the Cloud SQL or AlloyDB instance, provided the firewall rules like the appropriate ports are whitelisted, the source IP and the destination IP addresses have been whitelisted to allow ingress and egress traffics. So this would ensure that the folks or the people working in the other side of the cloud or the other side of the on-prem can actually connect to your services which are running on Google Cloud. So just expand it to a level, let's say, where we have some applications running across different clouds, different on-prem sites, different offices, buildings, and they want all to consume cloud services. You could actually use this connectivity as a means to establish connection so that they can actually connect to these services. Now, while this infrastructure looks pretty complicated, but the intent here is to automate this infrastructure, to use Terraform, Waypoint to help you scale up these resources, because as you have increasing demands, you will be looking for more such resources. For example, with the increase in demands, increase in usages, you would definitely be looking for multiple or number of AlloyDB or Cloud SQL instances, each managing their own workload, each managing their own use cases based on different teams, different groups, and so on. So that's the intent we want to highlight. Like the infrastructure like these that we're just showcasing could actually be automated using the appropriate tools in place, and the tools is what we wanted to highlight as part of this talk. So the next action is you should start with Terraform and Waypoint today. Start setting up your infrastructure using Terraform and how the app deployment pipelines would look like using Waypoint. Explore the use case for your organization's cloud infrastructure. Like you could use cross-cloud interconnect, you could use a dedicated interconnect, partner interconnect, or you could even look out for your HAVPN based on what are the use cases that you or your organization or your problem statements actually want to be resolved. So with that, feel free to reach out if you have any queries or looking for any collaboration, or you have any concerns around how this could be used for further simplifying your use cases or your problem statements. With that, I'd like to say thank you. Hope this session was of use to you, and you'll give it a try with your experience on Waypoint and Terraform. Thank you.
Thank you very much for the insightful
Hello.
session. It was really helpful to understand the network security on multiple cloud. What's your thoughts, Sandeep?
I think I mean, if you're working in a multi-cloud environment, it's a complicated scenario when you have to deploy maybe to a similar application or many application altogether, different clouds, managing the complex network, and that's where the Waypoint and Terraform comes to play and make our life easier as devs. So yeah, it was a great session to get a idea of how to get it done, and of course you need to learn more, so you should be checking out those tools.
So just one quick note that whatever sessions are happening right now, those sessions are going to be recorded. So by any chance, if you have missed the sessions, don't worry, it would be available on YouTube within few days. So stay tuned for the next upcoming videos on YouTube, which are all being missed for you, and enjoy the next session. So what's the next session, Sandeep?
So next session we have, let's welcome Neil Shah, and it's about Vault best practices securing your application with HashiCorp.
So let's welcome Neil for the insightful talk. Here you go.
Hello all, welcome to HashiTalks India 2024. Yeah, we will see the world's best practices securing of our application with HashiCorp Vault. So yeah, hi, this is Neil Shah, a DevOps community guy, working as a developer advocate and middleware, building DevOps communities like UDG Cloud, CNCF, Docker, HashiCorp in my local region, mentored 15 plus hackathons, and yeah, I've given talks in 10 plus conferences. So let's deep dive in Vault. Before that, let's understand the basic of Vault, how it works, and what are the fundamentals of it. Vault is a secret manager, a central secret manager where every credentials, every API certificate, SSH keys, everything can be stored at a single place. And Vault is cloud agnostic, so it doesn't depend which secrets are from which service app services of which cloud. So it doesn't depend. You can connect all things with Vault and have a centralized secret manager, a universal secret manager for your applications. Yep. So yeah, here is a basic architecture of Vault. So I will focus on major thing like Vault is path-based secret manager. How the routes are in the same way Vault is path-based. So the secrets will be stored on that path. Let's say if you want to store a key value pair at XYZ path, then Vault can store that at that path only, and you can only access if you have access to that path only. So yeah, we will see all these things. Apart from that, Vault has a very good audit log sort of thing where each and everything which is occurred on Vault server will be logged there. So it will be seen like who has changed the password and everything there. Apart from that, it has token store, expression manager, everything. So it is very fascinating like how the leads work here, how the token period is working here. Apart from that, here there is storage backend. Storage backend majorly people prefer as console or S3 or any sort of thing which can work as backend. Yeah, let's go ahead. So what are the main purposes of Vault? First is secrets management. Next is dynamic secrets, encryption as a service, EAS, access control, and which I prefer is audit logging. So why use HashiCorp Vault for security? Why people and many organizations are using it to secure their passwords, credentials, anything. Centralized secret management. You can store API keys, database credentials, certificates, yeah, single place. So if everything are at a single place, you don't need to go and search for every secrets, and there are less chance of leaking storage if the passwords are legal sort of thing. Because you will always have a keep your mind and an idea at a single place. And many times what happens is, as a developer, where we save a password in notepads in Excel, in sticky notes between the keyboard, behind the keyboard. Yeah, instead of that, you can use for secret manager. Next is dynamic secrets. Yep. So dynamic secrets can help to have more secure sort of thing. But yeah, it depends. Instead of using why we prefer static and dynamic. So as a developer, we will prefer dynamic. But if we talk to any like expert people, then they will say it depends on use cases. But yeah, wherever it is possible to use dynamic secrets, then you should try it out because after a preset amount of time, these credentials are expired. So you have lesser chance that anyone can access your application and it will minimize the risk of unauthorized access. So yeah, it is beneficial, but yeah, you also need to consider the use case, the environment where you are using the dynamic secret. Next comes, take an example, simple example, how the key value pair of secret manager works here. So here's the application, and kv/secret/app is the path where we want to create, where we want to access the secrets of application. So it will go to vault. Vault, every secret has their access policy associated with it. So it will go to access policy and will see that this application or this person has access to this uh, value or not. So if it has value, then it will get the value from the secret manager database and then it will pass on to the application. Otherwise, if it doesn't have access, then it won't show. It's the same as simple logic. But yeah, here the main concern is every vault secret have a policy associated with that. Next comes access control and audit logging. So security teams can definitely monitor access patterns, like who has access and who are trying to access. If a secret is accessed from an unfamiliar IP or at an unusual time, vaults logs, as I previously told, like as application logs are stored, similarly audit logs are stored in vault. So everyone can see like who has accessed the application and has get the secrets, and if some unfamiliar IPs are trying to get, then you can help and respond to that in real time. So that's a main concern and main problem can be solved over here. Even as a small organization or let's say big organization, everyone needs a security, and those companies who are working with some data sort of thing, they they need more security sort of. So yeah, this is one of the benefit of using Vault there. Data encryption and secrets rotation. So data, like let's say one example. So secret rotation can be done because every token, every secret, let's say every token, they have lease period. So after that lease, if you don't renew the lease, then the token will be expired. So in same manner, you can also assign like having dynamic secret, but with this time period. So after that time period, it will directly rotate. So what is the benefit? So this approach ensures that compromised credentials are short-lived because you are rotating the credentials. And the next thing is Vault has a transit secret engine. What does transit secret engine does is they will encrypt each and everything which you are stored in the storage backend. So and Vault only have the secret, the cipher code with which they can encrypt. So everything is encrypted before storing in the backend. And even you, if you want to uh, translate, like if you want to decrypt or something, then you can use translate secret engine, and you can only see what is the secret code there. Apart from that, what are the benefits of securing vault access? Reduce risk of unauthorized access, obviously. So you don't want anyone apart from your organization or some people of your team can access. So by implementing this, you can implement it there like airbag, access-based, identity-based authentication. Vault minimizes chances of unauthorized access. Audit-ready compliance, because as in IT, we also need every like we also have audit of softwares. So it directly creates audit logs. So there are not many risks sort of thing. You can utilize this feature and it will be very handy, your audit reports. Next is operational security. Secure access practices will help you to have your environment without compromising sensitive data or secrets, as if they are stored in an encrypted way, and every of your secrets are a single place and with their access policies. You don't need to concern about how different uh, secrets are compromised or not, because everything is secure all in a single place. Next comes, yeah, this is the main point which I would prefer is most of the people who have used Vault may know this, but yeah, some of might not know. So in Vault, if the main cluster, let's say Vault server collapse, then what happened? Is disaster application. So let's say how a worker node, the main server, and they have small server which are working as workers of that. Then same method. These are disaster application and performance application. So disaster application occurs when your main server collapses due to some reason, but your applications are running on. So what it will happen is it will mirror all the tokens, leases, along with root tokens, everything to another server, and it will be working till that portion. But when it comes to performance replication, so not everything is replicated. It will it will mirror the primary cluster. It will mirror the backend, the authentication method, secret engine, but it will not mirror the tokens, and it will be as a secondary cluster, not a primary. So where does the performance replication help? When your cluster is in some XYZ region and you are facing some bandwidth issues in some other region. So your application performance shouldn't be reduced here. So to increase your performance, it will create another secondary cluster, but it will work as a secondary only. Otherwise, it is promoted to primary. It will work as a secondary. It will only give the local secrets stored in that, and not have all the XCS root tokens or anything. While in disaster replication, the cluster which is newly made has all the XCS, which has a primary, which is similar to a primary cluster. So you can see how here works. So performance primary directly goes to DR, that is disaster application, if some disaster has happened. Otherwise, it will go to the secondary for the performance sort of thing. What are the best practices for secret management involved? Avoid hard coding secrets. Don't use secrets directly in your application. You can use Vault's API and directly get the secrets from Vault using the API. Implement Vault client-based libraries or scripts in your application to fetch secrets securely without any hesitation there. Next, use short-lived secrets. Set an expiration period on secrets based on their usage requirements, and rotate or renew them regularly. So that is a best practice. Use short-lived, and if you want to create bulk tokens and everything, you can create short-lived bulk tokens because you know that after this much amount of time I don't need, so I can regularly replace them. So yeah, this helps a lot. Automate secret rotation. So what is this benefit? Rotation, it simplifies secret management and reduces the risk associated with the stale or unused or previously used tokens where they are not in use for quite a long time, improving overall security posture of your application. Because many a time what happens is we had used some secrets of some application long back, but we don't know. Then after some time it should be revoked there. Next is enable environment specific namespaces. So as know as I told already, like it is a path page. So the same way we can also have different subpath, different paths as day out as prod, and have different passwords and that. So people who have access to Dell won't have access to test production and won't have to live production. So yeah, you can separate them and it will be beneficial because as in it will specify you can access to this only, you can access to this only. Yep, in that manner. For use cases and real world applications, I will walk through it very fastly. Secret management for microservices. As in microservices architecture, you have different sort of microservices and different compartments of your applications, containerized applications. So yeah, you can use Vault API and directly fetch the secrets from that. Reduce the risk of cross-service credential leaks. Here you don't know how the credentials sort of system is working there, and each service in the microservice segment requires some of the secrets. So you use Vault API and get a secret from there directly. Apart from that, securing access and CI/CD pipelines. So most of the organization have CI/CD pipelines, and they inject secrets sometimes directly during the pipeline execution. So you can authenticate Vault with your pipeline and directly get the authorization of your pipeline from through that. So it will directly reduce the accidental exposure of your passwords. Next is identity based access. So what we told as IAM, we can also use this for every of the cloud directly. So instead of having IAM for different cloud, you can use this as a single platform and have everything as a single state. Encryption as a service. It allows secure secure storage of your password and data is encrypted. Each and everything is encrypted here for sensitive information such as personal data, healthcare records, payment information because they are very secure and many organization in this frame pays a lot of thing for securing their storage. So yeah, here are some of the authorization methods which can be key value peer databases, transit engine, which I already told for encryption. Apart from that, it also helps in Azure. It can work in Azure, GCP, AWS. We can use Consul here as backend, and some of the authorization method can be LDAP, Okta. We can also integrate with GitHub. Apart from that, we also can use JWT tokens, OIDC tokens. We can also use PKI certificates over here. Yeah, here is a workshop site for you. You can quickly go through. It is created by HashiCorp people only. So you can go to it and you can directly utilize how what occurs, how what actually works, and at least see through it. Try it out once. Feel free to connect with me for any queries. Yep, thank you. Have a nice day. Enjoy all the other sessions in Hashita.
So that
that was a nice session. Yeah.
Yeah, that was another insightful session, I would say, Sandeep. I agree with you.
And Vault I also have been using for say last 3-4 years, and it's amazing. By the way, because you should not be storing your credential or say your it could be AWS secrets, it could be other API secrets as a normal repo. Okay, you should be storing in a very secure place, just like Vault, where it's encrypted and you can use it for anything. Maybe it's EKS cluster, or maybe any other cluster. Could be for any other. As if you require the credential, you can just use the Vault. Yeah.
Absolutely, I agree with you, Sandeep. So after the talk, it's time for some announcements. So let's start with announcement 1. That is a special announcement.
Yeah. So HashiCorp is hiring in India and looking for senior SRE, senior front-end engineer, product manager, senior performance engineer, and many other positions. So visit hashi.co/hire India, and we'll be sharing the link in the comments so that if you're interested, go and join HashiCorp.
Yeah. That's an interesting opportunity, guys. Don't miss it. And the next important announcement that I would like to make is if you are interested to join any HashiCorp user group within India, you can just check the meetup channel. Over there, you will see there are a lot of HashiCorp user groups. So if you are interested to learn within the community and join the insightful sessions that the HashiCorp user groups host, definitely check out. For that also, I would share the link of the page that I think it's already available right now in the comment while I'm talking. So please visit to that website to check out that which HashiCorp user group is close towards to you, and you can join it. And the last and important announcement, once again, that remember we will be sharing all these talks videos on YouTube. So by any chance, if you have missed it, don't worry, it's all recorded and it is going to be available for you for your further learning. So with that, I think it's time for us to close this fantastic event. I hope you all have enjoyed the event, and it was really a great learning experience for me, Sandeep. What about you? What's your thought?
Yeah, I mean, lots of useful sessions, and it's not just learning. It's about what you learn, implement in your practical life, implement in your projects, and that is where your real learning will happen. Okay, because because without practice, or kind of applying all the changes, you will not face the challenges. If you face the challenges, then only your thought process will help you to fix and learn more. So it's all about learning and implementing. Okay, and all the sessions were very practical.
Yes. So thank you guys for joining. I hope you had you had enjoyed the insightful sessions and took a lot of learnings with you. So it's time for us to say goodbye. Thank you, and bye for now.
Bye.